I put a spell on you. Because you're mine. Stop the things you do. What's up? I ain't lying. Yeah, I can't stand. Woo! No running around. I can't stand. No putting me down.
Hello. Thank you so much for coming today. I hope that you had some fun with our steampunk artists today. And you probably already noticed that the theme for this year is steampunk. So my name is Roberto Cortez, and I'll be your host for today. Um, I hope that you're having fun already, and we have a lot of other surprises for you. So before we actually start the event, let's go with some basic ground rules and some basic information I want to share with you. So let's go. First of all, welcome to Jnation. We're really happy to be here after 2 years where we were basically only online, and we know that those years were a little bit difficult for everyone. So we're really happy to be back as a physical event, and we hope that we're able to keep coming as a physical event. Now, numbers for Jnation 2022. So we have 800 attendees, so almost a full venue. We're really happy about it. 38 speakers coming from all over the world, and I mean really over the world. We even have people coming from Australia. That's really great. 30 volunteers. Thank you so much for all the help you've been giving through the entire event. We have 5 tracks this year, so we added an additional track. I'm going to talk about that a little more in the presentation. We have 31 sessions, so we also increased the number of sessions. So we have a lot of content between Java, JavaScript, cloud and containers, a lot of stuff. So we try to make a good program for you to be able to find something that you will enjoy seeing and learn, of course. And these will not be possible without the sponsors. So we have 28 sponsors this year. We're really happy with all the help. So thank you so much for all of them. Now, conference itself, as probably some of you already know, is organized by the Coimbra Jug and with the support with other jugs from the country. We like to do it here in Coimbra. I know that sometimes it's not really that easy for people to get here. But on the other hand, we have this awesome venue. You'll see it through the day. We like it to do it here because we are in the center of the country. So we want to still make it in Coimbra, and there is a lot of people in Coimbra that love to have Jnation here, love to help us. So yes, we really enjoy that. So this is our team. This will not be possible without the dedication of all these wonderful people. So not only the organization team, but the volunteers are wearing red shirts. So if you need anything, please talk to them. And if you come across any of them in the hallways, please hug them, because they've been amazing and fantastic, and this will not be possible without them. This also will not be possible without all of these amazing speakers, right? So this is one of the main reasons why you come to this conference, to hear these amazing talks by all these amazing people. And I cannot thank them enough for them to take some of their time to come here to Portugal, come here to Coimbra, and bring us the greatest and latest of all the technology. So thank you so much for all of them. Now, as you know, the ticket prices that we have for Jnation, we try to put them the less amount of possible, right? And this is only possible because all the money that we get from the sponsors, right? Without the sponsors, it will not be a conference. So for you to have an idea, 80% of our budget is coming from sponsorship. And that allows us to have the ticket price as low as we can, so we can open the conference to pretty much everyone and try to make it affordable to all of you. So for this year, we would like to welcome Platinum sponsors, LX Group, Mindera, Red Hat, and Sky. Thank you so much for all your support. We also have a lot of other gold sponsors today, so thank you so much for all their support. And also, of course, silver and bronze sponsors. So please go and check the stands area. So again, this will not be possible without them, so we cannot thank them enough, because without them, of course, it will not be a conference. If you're familiar, or if you've been here in 2019, so actually, let's do something funny. Who was here in 2019? Oh, wonderful. Maybe, I don't know, 80% of the room? So thank you again for returning. So who's here for the first time? These numbers doesn't add up. OK, never mind. So as you've probably seen, you have, well, I don't have my badge here, but you have like one of these tokens on your badge, and you can trade them from other stuff in the conference. So the way that you get more tokens, you go to the stands in the sponsors area. They'll give you tokens. You can trade them for whatever things you want. So check your badge, see what things you're interested, and you can go to the end of the room. There is our stand over there, and you can trade for stuff. So this is a way for us to thank the sponsors and to thank you for being part, and you can take a gift back home, one or more, depending on how many tokens you get. So it's a quite nice thing to do. So here are a couple of things that you can get. So these are on their badges, so please have a look into them. And we also have our Jnation app. So you can download them on iOS or Android devices. You're able to see the schedule. You're able to even scan the QR codes of your badges to keep your contacts from people that you know. As you know, Jnation is also a networking event. So please feel free to use the app and have fun with it. Finally, we also would like to welcome Quarkus. So maybe some of you have heard about Quarkus, maybe some of you haven't. But this year, we're really happy to host the first ever Quarkus full track event that we're going to have over here on Jnation. So that's the fifth track that we added. And we have a bunch of people from the Quarkus team. So if you're interested in these kinds of technologies, please go talk to them or just go to one of their sessions. I think it's going to be very interesting. And again, thank you so much for Quarkus for coming here and sponsoring our event as well. And that's pretty much it. Please enjoy. Remember, at 6:30, we end the event, and then we're going to have an after party later on. So you can come, drink a couple of beers, have a couple of snacks, and network a little bit more. And we hope that you will have fun on the event, and let us know if you have any issue, and we'll try to help you. So without further delays, I would like to welcome Steve, my good friend Steve, please. So Steve will do the keynote for us. Oops.
All right, so thanks so much for having me again at Jnation. I was really excited to be invited back to speak at Jnation. Roberto, who this conference wouldn't be possible without him, invited me to speak at the first Jnation event, and I'm really, really excited that we're back in person. We can have events like this again, and I get to reopen Jnation post-COVID. So thank you all for coming. And my day job is I run developer relations at JFrog, but I think one of the big things which is trending in the industry and we all need to understand as developers is open source supply chain security. Now, like any complicated topic, I think it's best explained with sci-fi references. So we're gonna hopefully explain everything you need to know about open source supply chain security purely with sci-fi references. So let's see how this goes. So I think, first of all, you know that open source software is just used everywhere. Your typical enterprise application has 80 to 90% of the code base is dependencies on open source projects. So the majority of the code you're running in production isn't code you write, it's code which you depend upon. And I think this is kind of the crux of what's happening is now it's both exciting and scary time to be a software developer because if your parents or family members watch the news, they've probably heard about different supply chain attacks. So they might actually know what you do for a change. I'm used to just being a developer who codes in a closet and nobody knows what I do. So having things like, this is a historic example. So the Equifax breach, I think this highlighted the risk of supply chain security in the context of zero-day vulnerabilities. But what's happening is, as we move along, the range and the type of attack which is happening is becoming more invasive. It is more targeted at companies and attacks at specific organizations. And they're increasingly using open source supply chain. SolarWinds was a good example of this, where they attacked the CI/CD pipeline, injected malicious code right before they did the code signing. So it was actually an implementation where they injected malicious code that would open a backdoor when the SolarWinds software was installed on site, and that allowed them to exfiltrate code. It wasn't discovered until they found the actual data being exfiltrated from different government organizations. And this prompted the White House security order, which, among other things, mandated and recommended SBOMs for government organizations. And we're increasingly see this trickling down to consumer organizations as well, where it's becoming essential that you have a software bill of materials, that you have traceability of all your open source artifacts. And just a few weeks ago, on the anniversary of the White House security order, we had an open source summit at Washington, D.C., which I was part of. I'm also on the governing board for the OpenSSF Foundation. And we had government officials saying, OK, a year later, we mandated SBOMs, we got the whole industry behind improving open source security, and now we have lots and lots and lots of SBOMs that we have no idea what to do with. So security is better, but it's still a huge issue. And I think this is one which affected all of us and was recently highlighted, was the Log4Shell vulnerability, where if anybody here use Log4j, just raise of hands. OK, a few people in the audience. And this highlighted how vulnerable the industry is with a zero-day exploit, which had been in the code for a while, and was exposed recently and forced us all to quickly patch if we were using the higher-level Log4j libraries. Of course, if you're using the Log4j core, it wasn't affected. But the basic attack mechanism here was that you could inject a JNDI URL, which would call back, and then this would pull back code, which would execute maliciously on the machine you were attacking. It's very easy for you to test for this, so you can poke and you can test different servers to see if they have this vulnerability, so it makes it easy to scan and look for affected services. And then this would give you arbitrary code execution on the target machine, which is the holy grail of supply chain security attacks. So I think that this is something we all dealt with earlier this year to patch. Spring Shell followed shortly, which was a similar vulnerability. And this highlights how important it is for us to secure the open source supply chain upstream. So I think this represents the tip of the iceberg for potential open source vulnerabilities. There's a whole lot more of them out there. There's a whole lot more work we need to do to secure open source software, and also to make sure that the enterprise software we build and depends upon it is secure. So how many of these different repositories do folks use? Anyone use NPM in the audience? OK. I have some security exploits for you. Anybody use PyPy? OK, I have some for you too. And how about Ruby gems? OK, not today, but we found security exploits in all of these central repositories. And I think that one of the challenges is that as developers, this is the source where you easily get package management, you pull down dependencies, you pull down libraries from these sources. And the attackers know this, and they're finding different ways which they can exploit this as a vehicle for injecting malicious code into our enterprise software. Now, I think a high-level way of looking at this is every time which you are doing a pip install, a go-get, or an MVM fetch, then you're basically doing the equivalent of taking a USB drive off of the pavement and plugging it into your production servers. So if you can imagine, this is something we've all been taught from a security standpoint. Don't plug random USB drives into your computer, you'll get a virus. So this is the equivalent for enterprise systems and for servers. And this highlights how important it is that we all work together to secure these upstream repositories which we depend upon. Okay, so like any good presentation, we're going to use some sci-fi references. So anybody know this film? Just shout it out. Okay, good. So we all know the Matrix. Now we have all the main characters for the Matrix here, right? But we're missing somebody really important. I think this person is the star of the Matrix show, and of course it's Agent Smith. Oh, Roberto. Oh, okay. So if you watch the movies, okay. How's my pronunciation? Okay. I got it. Okay. So if you watch the latest movie, this was a travesty in my opinion. This isn't Agent Smith. So they recast Agent Smith with a different actor. They gave him, I don't know, a weird role in the movie. He wasn't even the main bad guy. But these are the real agents, right? The classic agents. And I think the agents of the Matrix are a really good way of describing the next attack, which I'm going to talk about, which is a dependency injection attack. So like in the Matrix, the agents they take over different people's bodies and they'd consume them, and they'd use those as a proxy to then try to get the main characters. And this is exactly what happens with the dependency confusion attack, which was done by Alex Spierson, and it's a clever attack which hijacks your corporate dependencies by taking over the namespace. So this is the exfiltration technique. So once they get inside your servers, they're using a custom DNS server to then bounce traffic back, and this is how they actually get some of the data out of your network without it being spotted, because it's all masked as DNS traffic. The actual attack was based upon package binding, so they would use this to figure out what dependencies you had internally to get some of your internal namespaces. So like for this example, these are some internal libraries used by Yelp. And the way the attack works is when you, inside of your internal network, go to fetch a dependency, let's say the latest version of your awesome corporate library, normally what you would expect is that it's going to go to your internal server, but they publish a newer version on the central repository with the same name, the same group ID, and then you fetch the one from the external repository instead, because your vulnerable package manager doesn't know about this. And then bad stuff happens. As we know, don't put big red buttons in front of kitties. Now, one way to stop this sort of attack, and we've fixed this specifically with our package management system, Artifactory, is if your package manager is smart enough to know that it's an internal dependency, that it shouldn't go out to an external repository to fetch it, then you can block this sort of attack from happening and make sure that you only go to open source repos for open source libraries, and you only go to your local dependencies for local libraries. You would think that this has been patched and that most companies now aren't vulnerable for dependency injection attacks. But just a few weeks ago, we found an example in NPM where they had a dependency injection attack with some new modules which were checked in. They were specifically targeting an organization. It was all internal namespaces from a particular company. We contacted NPM, had the libraries pulled down, and then published our findings on our security blog. The group who took credit for it was a security research firm. So they said they were just testing for vulnerabilities and essentially making sure that they didn't have these sort of attacks for their clients. But this is a very prevalent attack and also a very profitable one. Alex Spierson did multiple different bug bounties on this and collected 130,000 from folks like Apple, Facebook, and a whole bunch of other Bay Area companies, all off this single dependency injection attack. He basically proved this across a dozen different organizations simultaneously and scooped up all the bug bounties for it. So maybe a new career, if you have a good security exploit, do some bug bounties, and then you don't have to code for a living. Okay, so the next example I wanna do is I think since we're doing the science fiction theme, we definitely need to have a Star Wars reference, and I think the best example of this would be the Millennium Falcon, which oh, what's wrong? Okay, so anybody been to the DevNexus conference in Atlanta? Okay, a few folks. One of the speakers last night at the speaker dinner was wearing one of the DevNexus shirts, and Vincent Myers and I, who ran the conference, we did a mix-up of the USS Enterprise and the Millennium Falcon. And on the ship, we actually had like the head of the USS Enterprise, or no, it was the Enterprise, and then it had the little thing at the edge there for the Millennium Falcon poking out of the dish, which I think is a fun mashup. But the Millennium Falcon, as an example, as you know, is a smuggler's ship. And one of the ways which you get vulnerable dependencies into different organizations is by smuggling things which shouldn't exist in those repositories. Why would you trust a guy like this, right? So I think actually we have a better person in the community who represents this. Does anyone know Han Solo on Twitter? Okay, so a little more trustworthy, right? But from a dependency standpoint, PyPy as an example is a great place to smuggle and to put things. And it's extremely easy for you to upload different packages into PyPy. So as you know, PyPy is the package manager for Python. You just do pip install to install new packages. It downloads and installs from PyPy. And it's very, very easy for you to upload new dependencies. So our research team scanned the whole PyPy repository. They were looking for different malicious vulnerabilities inside of it. And this is one of our researchers, Svetter. So he's actually one of the guys on our new Israeli research team. And he has this awesome PyPy module. You can actually check it out in PyPy. It's still there. It's called Svetter 0.8. And it does extremely valuable functionality, which is it opens his website. So if you install it, it will pop open his website. So if Svetter, one of our security researchers, can stick a random module in which is going to open his website, the attackers can do this very easily too. And when we scanned the whole PyPy repository, we found 300,000 of the 300,000 packages there. We got 6,000 hits on potentially malicious libraries. We were looking for things which were doing evals with constant inputs, so that would be an example of an obfuscated code. Trying to read-write sensitive files, spawning command shell pipe to network socket, and evaluating arbitrary strings from the network as code. All these things are things which you wouldn't normally expect libraries to do. And specifically, we found a couple exploits which we could reverse engineer and figure out what they were doing. One was Noblesse, optimizes your PC for Python. It actually steals your credit card. Another one was Pythagora, make the Pythagorean theorem easy, and it would run any Python code received as string from the network. And both of these packages obfuscated their code, and together they got about 30,000 downloads. So it was something else about the way which both PyPy, NPM, and a lot of the package managers work. This isn't true for Java package managers. When you first install them, they have install hooks which run, and so you don't even have to run or depend on the library. Simply by syncing the library down or having it synced by a dependency, it will run the install hook and immediately execute the malicious code on your machine. And the way in which they would get your credit card, for example, is while your browser is designed to be really safe against websites getting access to your credit cards, right? So it's nicely partitioned off from JavaScript code. You can't get direct access to the database. At the end of the day, it's really just a SQLite database. And it's not even password protected. So you can go in there, you can get the SQLite database, you can decrypt it just using user credentials. So you call crypt unprotect data. And any locally executing code can directly get access to all of your passwords, credit cards, and other information stored in your browser. So think twice before you save your credit cards and other stuff in your browser. And this is the actual code, which would steal the credit card once it was deobfuscated. So you can see it's not a lot of code. It's easy to do. And again, this gives you an easy way to see how dangerous these sort of supply chain security attacks are. This is an example of doing things on the local machine. So it's common for these sort of systems to steal credit cards, steal Discord Nitro tokens, and often they'll exfiltrate the data through Discord as well because they want a protocol which wouldn't normally be flagged by software looking for firewall breaches. But increasingly, we're seeing folks use these sort of attacks to attack companies. So if you are targeting a specific company, getting access to developer machines, getting access to corporate resources allows you to hop internally and then execute attacks against corporate networks. OK, so I have another sci-fi example. So this is a fun game and a really classic one. So we have the old school war games, right? And if you remember the movie, it was all about basically computers executing AI and playing a game to do a war simulation. So in our war simulation, we have to pick some countries or some cities to bomb. So I need just shout out some example cities. Give me some cities in Russia that we should bomb. Just shout them out. Moscow. Any others? St. Petersburg. I heard St. Petersburg. I heard Moscow. OK, let's go. So let's do Moscow first. Moscow. What's wrong? OK, so this is Moscow in Idaho, right? OK, that was a bad example. I mean, we forgot to say what country. St. Petersburg, we got this. Uh-oh. Where's the OK? OK, so this is a simple example. Obviously now we've blown up the US, so you guys are safe here, don't worry. But it's an example of leaving off the prefix, right? We left off the namespace, and therefore we chose the wrong package. Now, before we go on, we're making fun of Russia, but I think on a more sensitive note, I think we're all very concerned about the situation going on with Russia, Ukraine. We were chatting at our table last night at the speaker dinner about how we all want to help and are finding different ways which we can help out by helping on the border or contributing in different ways to relief aid. And one of the things which we did recently at JFrog, which I was proud of as an employee, is we sent a mission of different employees out to help on the border. So they landed in Poland. They went to the border, or in Czech Republic. They went to the border between them and Ukraine. And they brought different supplies and relief for folks there. Obviously T-shirts, because you need clothes as well for relief aid. Here are some of the workers. We tried, just for sensitivity, not to show pictures of refugees in the photos, so it's mostly pictures of employees for that reason. and of course, frogs. So I think that it was really great that we were able to do this sort of humanitarian work. And I think also something which is rare is the person on the very right of the photo there is the CEO of our company, Shlomi Ben-Haim. And he not only joined the missionary work, I don't know if our board of directors and investors were happy with us sending our CEO to a war zone. But he also worked on the front line, helped out, and he ended up getting COVID as well on his way back. So he was trapped in Israel for an extra week. So I think that shows that, the sort of dedication and care which our leadership really has. Okay, so getting back to the technical part of the talk. So I was talking about leaving off namespaces and prefixes in the previous example. And this is exactly the sort of exploit which we found happening for libraries in NPM, where it was targeting developers using the Azure libraries. And for example, this is Azure Core, if you're coding against the Azure cloud. And if you happen to leave off Azure and just do core tracing, this is the package you would get back. And so they took all of the different namespaces for Azure. They put in fake packages so that if you accidentally left it off, you would pull down these packages instead. This is a classic typo squatting technique. And they even went so far as to use different users for each of the different NPM modules which they published to make it less obvious that this was a security exploit, and also to make it harder to find all of them at once. So there were 218 packages they checked in, which were like this: Azure, Azure Test, Azure Tools. The code would exfiltrate personal information from the developer machines once it was installed. And this, when we caught it, it seemed to be just them testing to see how many vulnerable instances there were. So this was basically testing out the typo squatting technique. And we were able to get NPM to obviously pull down the packages, and then we published the security info about this. But this is another example of organizations, malicious hacking organizations, finding different ways to use public repositories to gain access to developer machines and ultimately to corporate networks as a way of getting in. So all of this information on these exploits and more can be found at the JFrog research site, research.jfrog.com. We publish the security exploits. This is also where our research team, which does all the zero-day exploits and data input for X-Ray, our security scanning tool, also works. And it's a good resource just to find about open source dependencies and the vulnerabilities which are there. So as we talked about earlier, we can solve this all with SBOMs, right? Oops, I went too fast. So we have the Salsa to help us. Okay, so Salsa actually stands for supply chain levels for software artifacts. This is one of the OpenSSF projects where they mapped out the different potential dependencies for where you can get vulnerabilities, and they have different levels that you can certify yourself or look for projects which are certified to see how many of these different exploits which they handle. And from the start, you can get a lot of vulnerabilities coming in from source control systems, from compromised build servers, but then even dependencies and package management systems are also potential vulnerabilities. And if you want to secure the entire software supply chain, you have to secure this end-to-end. So one of the things which we're working on as an open source effort is building a project to secure the open source supply chain, which is automated, kind of like Iron Man, trustworthy. I'm not sure a Russian spy is a good example of being trustworthy, but Black Widow, and dependable like Captain America. And the open source project we announced, we just kicked this off last week at the Swamp Up conference, is called Persia. And this is a collaborative effort with a bunch of different companies in the industry to build a system which solves a bunch of these class of software supply chain vulnerabilities by design. The name Persia comes from the Greek reference to a communication system which they used to communicate over long distances using torches. So they'd put 2 rows of 5 torches on a mountaintop, and then they'd map those set of five torches into a grid to communicate the Greek alphabet, so you get up to 25 letters. I guess they only had 24 Greek letters. And this is how they would communicate over long distances. And we think in the same way, we can communicate software supply chain and create a more reliable system for doing this using open source technologies. So the goal of Persia is to be a reliable network, to be secure by design. So when you're pulling dependencies from it, you don't have to worry about namespace attacks. You don't have to worry about malicious code or like tampered binaries. And also that it's entirely open, so that you have both your repository software is written in open source, and it's a decentralized network which is not controlled by a single company. It's over an entire set of companies which collaborate with this. So the first part of this is the binary distribution network. We just released a system which allows you to do peer-to-peer downloads of container images for Docker. We're using the official Docker images. They're one of our partners on the project. And as a developer, you can download from other nodes of the network. You can download from other nodes running the Persia system, or we're running trusted package repositories, which act as the source of trust in the network, and these provide the images which are available, and then also the immutable ledger so that you can get information about the entire history of what's transacted on the network. So as a developer, you can get your binaries more reliably because you don't have a single point of failure. You can get it from multiple sources, so you can be getting it from local sources, which will be faster than pulling it from places on the internet, or if you don't have great connectivity, you can also get it from local sources. And it gives you the kind of that verification and trust that you need to know exactly where your binaries are coming from. Phase 2 of the project, which we're working on now, is multi-node verification of build. So the idea is that rather than relying on a single source to build all of your binaries, you have multiple servers building in parallel. You're comparing the hashes of those, in the case of reproducible builds, to verify that it's exactly the same output file. And then only the binaries which pass verification are available from the network. So this, for example, would prevent the sort of attack which happened with SolarWinds, where a particular CI/CD got hacked. You would have to hack multiple companies' CI/CD servers, which are building the binaries simultaneously to actually attack the network. For the consensus algorithm on this, we're of course using blockchain technology. Not cryptocurrency blockchain, but this is just blockchain as a immutable distributed ledger. And the specific consensus algorithm we're using is called Aleph BFT, Byzantium fault tolerance. So there's a great research paper written in 2019 about how the technology works, but I think one of the unique things about it is it's an asynchronous protocol, so it's quite fast as compared to some of the older consensus algorithms. If you ever used Bitcoin, you know that it takes several minutes for transactions to clear fully because of the number of nodes and the synchronous nature of how it does transactions on blockchain. In this case, we're using a DAG, a directed acyclical graph, and post-verifying using the Aleph's algorithms for what the next block is in the chain. So this both makes the network faster, but it also makes it resilient to outages as well. So up to a third of the nodes of the network can be compromised, and you still get the same performance. It'll still have the same throughput of transactions. Up to 2/3 of the nodes can be compromised. You have to compromise more than 2/3 of the networks in the node to actually get any data corruption. So for you to effectively attack the network, you have to take over the majority of the nodes in the network, which I think gives a really strong guarantee that the network is secure, that it's high performance, it doesn't get impacted, and that it can be a stable and reliable way for you to depend upon your upstream open source libraries. The Persia project's being done in collaboration with a bunch of different companies. So Docker and Deploy Hub's an OpenSSF member company, have both been helping us out with the work on this. So we've been working on this for about the past 9 months or so. Also, Huawei, FutureWay, and Oracle just joined the project as well, and they're also contributing things specifically for Oracle. It's more about securing Java libraries and focusing on the Java space. FutureWay and Huawei have some very interesting technology for doing secure Docker containers, where you can isolate the Docker runtime entirely from the host machine, so that gets rid of one potential attack vulnerability, where the host machine could affect what's being built. So I think that these are both great contributions to the project and should help us a lot as we're moving into the second phase to do the build from source and verifying of images across the network. Okay, so this is already happening. The hackers are out there. They're targeting us as developers. I think this is one of the big changes we've seen in the past year, is it's gone from attackers attacking corporate networks, attacking enterprise software, to they're using us as developers for the vehicle to get inside. We need your help to make this possible. So we need everybody's help in the open source ecosystem to solve this problem. It's bigger than just any individual or any company. And I need all of your help. So I think a lot of folks know this, but I historically ran the Java community keynote at Java 1. And we had a lot of great, this was our Matrix keynote. We had a lot of really great presentations and keynotes where we'd have all the community members on stage. Anyone know this guy? No. So when I gave this presentation at the DevNexus conference, thank you, man.
Thanks, man.
What we did is we brought the whole DevNexus audience on stage and took a photo. Now, I think we can do better. What do you think? Can we outdo these guys? All right, so we need everybody's help. Let's get the whole audience up on stage for a photo, and let's help secure the open source supply chain. So help us secure the supply chain. Come up.
Come on, people.
And direct people to go to the left. Yeah.
Go to the bottom. Então, Sérgio, como é que tá? Pra ali. Careful with the hole.
Okay. Welcome.
I already asked for that.
So we already checked with the venue. We're sure that the stage can handle the weight capacity of the attendees.
If not, please tell us no.
I like the sign.
Hmm?
The sign's really nice this year.
Oh, it's the same one.
Is this the classic sign that you guys always had?
Yeah. Please careful with the sign. It's really fragile. No, it's the same. It was the one that we have on the church.
Nice.
When you came. See, this is the auditorium.
Yeah.
We didn't use it. We didn't use it when you were here the first time.
Yeah, I thought this was the same venue, so we just didn't use this.
sabe. Como é que tá?
Why?
Okay, no. I think we're running out of space.
Oh, bro. We can sit on the edge here.
Possivelmente. This was the gentleman. I mean, he only told me about this yesterday. We only have 4 minutes.
Yeah.
5 minutes. 4 minutes.
Okay. So I think we're getting close to
you.
capacity on stage. What I'm going to recommend is if you want to hop on the edge here, if you're in front, you can just sit here. Yeah, just sit in the front here. And then you'll get in the photo.
Yeah, I think we
Yeah, I
need to
think
know
we'll
align
be
people
good.
over here. That's okay.
All right, so we have our photographer in the center.
Just
Anyone
full-
else wants to squeeze in, just
Yeah,
stand
go-
in the front row.
Go in the front row now.
Yeah, just hop in the front row. All right, Roberto, come here.
Yeah, I'm going.
All right. So, we got everybody in the photo who wants to be in? Almost there. Yeah, just squeeze across the front row. All right, so here's being back from COVID. Jnation 2022 is leading the charge. Thank you, Roberto. Thanks for the Hall team, which put this event together. This is an amazing
Thank you, man.
community event,
It wouldn't be possible without you.
and I'm just glad to be here with
we're
all
glad.
of my friends here.
Yeah,
I have
we're
I have a
glad.
lot of friends.
So Philip is our photographer. He'll take a picture for us. Say hi to him.
All right, and raise your hands. Thumbs up. All right,
Okay.
everybody, have a great conference.
Thank you.
All right, let's get the photo off him and post it immediately.
Yeah.
Thank you. Good morning. Bon dia. It's me. So, Diagrams as Code 2.0. This is a talk about software architecture diagrams specifically. Why are software architecture diagrams important? If you want to be agile, move fast, etc., you need good communication for your team to move in the same general direction. And teams really need a ubiquitous language in which to do this. UML gives us a ubiquitous language to describe our architectures, to draw diagrams, etc., but many people have stopped using UML. Why? I've heard all the reasons. Like all of these reasons, teams have literally given me as for reasons they don't use UML. Some of these are good, some of these are not so good. And so what you'll hear many people these days saying is, well, the value is in the conversation, just draw diagrams on a whiteboard. And of course, there is some benefit of doing this. I'm not saying that whiteboards are a bad approach, and I do use whiteboards myself for upfront design exercises. But the problem here is there's no structure. And this isn't a tooling issue. If you go look up software architecture diagram on Google, you get stuff like this. And these diagrams kind of look nice, but there's no content behind them, really. So if teams don't want to use UML, where do we go? And really, this is my advice here. If you are going to use a boxes and lines style notation for drawing software architecture diagrams, make sure you do so with some degree of structure. And this is where my C4 model for visualizing software architecture comes from. You can find more information online at c4model.com. The C4 model is essentially a hierarchical set of software architecture diagrams that allow you to tell different levels of detail to different stories. Different stories to different audiences at different levels of detail. And it's 4 levels of diagrams: context, containers, components, and code. And the concept here is diagrams as maps. So if you go onto Google Maps and you want to find where I live, which is Jersey and Channel Islands, you can zoom straight in, you can zoom into Street View, or you can zoom out to get some context and figure out where Jersey sits. So yeah, it's a nested hierarchical set of architecture diagrams. I'm going to focus on 2 for the topic of this talk. The first one is called a system context diagram. And in order to draw a system context diagram for the systems that you are working on, for example, you have to ask and answer, of course, these questions. What's the scope of the system we're building? What features sit inside our system? What features sit outside our system? Who are the different types of users, actors, roles, personas who might want to use your system? What sort of things are they doing? And what system integration points do you need to support? Answer these questions, and you can craft up something like this. So this is a system context diagram for, in this case, a financial risk system. We've identified a couple of user types and a bunch of system integration points around the outside. So it's a nice high-level diagram, great for many audiences. To drop down to level 2 of the C4 model, what we do is we take that red box and we do the pinch to zoom movement, which I can't because I can't reach the screen, and we drop down to level 2, a container diagram. And the container diagram kind of encourages you to ask a different set of questions. So what are the major technology building blocks? How are we partitioning features across these things, so applications and data stores. This is what I mean by a container, not Docker, sorry. What are responsibilities, and how do these things communicate at runtime? Answer these questions, and you can craft up something like this. So this is literally a zoom in of that red box in the previous diagram, and here we're showing the applications and the data stores that make up this solution. Got a couple of web apps, some data stores, some Java command line apps. The C4 model itself is notation independent, so that you can do the C4 model diagrams with boxes and arrows. You can use UML, you can use Archimate SysML. The notation is entirely up to you. And really, the concept behind the C4 model is abstractions first, notation second. So that's really to set the scene for the rest of this talk. What we're here to discuss, of course, is tooling. How do we draw software architecture diagrams? What types of tooling do we use? Now, most people are still stuck with general-purpose diagramming tools. Who's using general-purpose diagramming tools here? Yeah, that's quite a few people. Visio, Diagrams.net, Draw.io, Lucidchart, etc. Right, these tools are fabulous. They're very fantastic, sophisticated tools, but I don't recommend them for drawing software architecture diagrams. Why? Number 1, you don't get any guidance. So these tools don't know you are creating a software architecture diagram, and they can't help you. So with the system context diagram from the C4 model, a system context diagram really just shows you people and software systems. If you're using a general purpose diagramming tool, you can add things like components to your system context diagram, which is kind of not really in the spirit of the C4 model. And the tool's not going to discourage you from doing that. A big problem is really that you're mixing content and presentation. This is something we stopped doing with HTML like 20 years ago or something. And when you export these diagrams into text-based formats, they end up looking a lot like that. And you can't diff these things either. There's a lot of stuff you can't do with these formats. These tools, again, they don't provide guidance. There's no consistency here. So something you'll notice with the C4 model diagrams that if you have a context diagram, when you zoom in to draw your container diagram, you end up copy-pasting elements across both of your diagrams because you're showing the same things on both diagrams, of course. It's very easy to start misnaming things. So you'll notice here the business user versus the report viewer. Maybe that's the same thing, but somebody renamed it once and didn't rename it twice. And that's an issue. As I said, it's hard to diff. You can't stick that in source code control and hope to figure out what changed in the diagram. It's just impossible. And of course, you've got very limited opportunities for doing any automation. Sure, with things like draw.io, you can give it a CSV file and it can create a diagram off that CSV file, but it's just kind of hard work. It just takes a long time. It's like it just takes a long time to draw these diagrams. When I was putting together these little example diagrams for this talk, what you can't see here is that arrow is not straight. It's like 1 pixel out either side, and you can't get it straight, and it's really annoying. And that's the sort of thing I don't want to have to be messing around with in tools like Visio. So back to October 2020, when we were all doing the pandemic thing, of course. Diagrams as code as a technique appeared on the ThoughtWorks tech radar. There's lots of diagrams as code tools out there that you might be familiar with: PlantUML, Mermaid, Dot and GraphViz. There's a tool called Diagrams, which is a Python-based tool, and something called the Structurizer DSL, which is what I'm going to talk to you about. So diagrams as code is essentially, rather than using a drag-and-drop editor to craft up your diagram, you write some text, you write some code, and then a tool will generate you a diagram from that definition. This is fabulous because it's text. We can version control these things. We can diff them so we can see the differences between versions of diagrams. We can use our IDEs to collaborate and do global search and replaces, and we can integrate these tool chains into our CI/CD pipelines so we can automate our diagram generation. For the C4 model, in terms of this tooling, there's something called C4 PlantUML. This is a set of open source macros for the PlantUML tooling. You include them, oops. I pressed the wrong button. You include them via some exclamation mark include statements, and then C4 PlantUML allows you to craft up a diagram using a domain-specific type language. In this case, we're creating a person and a software system with a relationship between them, and that gives us this wonderful little diagram at the bottom. And this is okay. It's like a better approach than many of the tools I've talked about already, but it still doesn't solve many of them. So for example, if you want to craft up 2 diagrams with this technique, a system context diagram and a container diagram, you have to create 2 text files. And you have to duplicate stuff across these 2 text files. What happens if you change the name of one of your user types on one diagram? Well, you have to change it on the other diagram. Now, yes, you can include things and create snippets for inclusion and common elements, and you can use your global search and replace features of your IDEs to make this easier, but essentially the responsibility is on you as the diagram author. If you want to make some changes, you've got to make them everywhere. I want to shift the narrative away from diagramming and towards modeling. Now, this is a very dangerous thing to say because we used to do modeling 20 years ago and everybody ditched it because it was very big and bloated and heavyweight and we threw it all away. And we shouldn't have done that. There is some stuff we did throw away, quite rightly, but the concept of modeling is very, very powerful. And what I want to do is I want to apply this in a nice lightweight way that's compatible with the way many teams work today. So I generally earn my living by flying around the world and running architecture training courses. And when the pandemic hit, I had no work. Like none. It all got cancelled almost immediately. So I did a ton of surfing, I did a ton of cycling, and I learned how to make proper coffee. I apologize, this coffee does have milk in. I get it. So in addition to this, I had a lot of spare time, so I created some tooling to craft up these architecture diagrams. And this is my structurizer tooling. Now, I want to make this perfectly clear here. I do have a company called Structurizer, and we do have some paid stuff. I'm not going to talk about any of the paid stuff, which is over here. Hidden away, see, hidden. I'm not going to talk about that. I'm going to talk about all of the free and open source tooling. So everything I'm about to show you today, you can use completely for free. And you can fork it, customize it, etc. So the main thing I'm going to be speaking about is called the Structurizer DSL. And it's a text-based domain-specific language specifically targeted to creating C4 model diagrams. It's all open source, so you can go find this on GitHub. It's actually a wrapper for a library I wrote about 5 or 6 years ago called Structurizer for Java. So this is an entirely Java-based toolchain. And the difference here between the Structurizer DSL and C4 Plant UML is rather than creating multiple text files to get multiple diagrams, you're crafting up a single model of your software architecture and generating multiple diagrams from that single source of the truth. So arguably, a better title for this talk would be Models as Code, but the problem with me putting this as a talk title is that it would never get accepted and no one would turn up, because modeling is seen as horrible and evil and bad, and I'm hopefully here to change your mind. So what's different about the Structurizer DSL? First of all, we're not talking about boxes and arrows, we're talking about proper domain concepts. So if you look at Plant UML has things like rectangle. So if you're using raw native Plant UML, it's just a rectangle and arrow, and that's not a particularly good way to craft up a software architecture diagram. C4 Plant UML, as I said, does provide you with some domain concepts, like person and system, but I want to take this a step further. So I'm also going to be adopting a very domain-specific language approach to this. So you'll see references to things like person and software system and container and component, and these are all words from the C4 model description. Number 2 is model-based. One of the things we always talk about in software development is don't repeat yourself. But when we're crafting up architecture diagrams, that's exactly what we're doing. We're copy-pasting boxes and lines from a Visio sheet to another one. So this is an example of the Structurizer DSL. What we're doing here is we're crafting up what's called a workspace. A workspace is nothing more than a wrapper for 2 things. Number 1, a model. A model describes your elements and the relationships between those elements. And number 2, a set of views. So what this example is showing you is essentially a model consisting of a user with the description user. I know. A software system with the description of software system. A relationship between the user and the software system. So that's the model. That's the elements and the relationships. And then we're defining a view at the bottom here. And we're going to define a system context view for that software system. We're going to tell the DSL we want to include all of the default set of elements. What this does behind the scenes is it says, right, you want to include the software system and things linked to the software system and apply automatic layout. So that little bit of code gives you this wonderful looking 2 boxes and 1 arrow diagram. Now, of course, imagine this is our system context diagram, and we want to pinch to zoom in to see what's inside the software system in terms of C4 model containers. What we do now is we extend and add to that single model. So now we're opening up some curly braces, much like you would with a programming language. We're defining 2 C4 model containers inside, nested inside that software system, a web application and a database. We now have 2 relationships that we're defining here. We have a link between the user and the web application and the database. We're keeping our system context view, and we're adding a container view. Include start, in this case, says include all of the containers inside the software system and things they are linked to, and apply automatic layout. So now this text gives us 2 diagrams. So now we're able to change the name of that user, regenerate the diagrams, and we can see those changes across all of our diagrams. Because this is model-based, we can start to do some quite interesting things here. And we can start to imply relationships that we don't need to describe explicitly. So in the first example I showed you, we defined a single relationship in the text, user to software system with a description of users, and that gave us this line. In the second definition I showed you, this line does not exist. But it's still creating the same arrow. And it's doing this because of something called an implied relationship. Because the user has a link to the software system, and the software system, because the user has a link to the web application, and the web application lives inside the software system, there is an implied relationship between the user and the bigger outer software system box. So that's being generated for us. One of the things here is you can customize all of this logic to make it how you want to. So that's quite cool. Separation of content presentation is something else I really wanted to achieve with this tooling. I'm a big fan of like HTML and CSS, and particularly this book from a long, long time ago, the Zen of CSS Design, and it was kind of groundbreaking at the time because it gave you this very skeleton HTML page, and then had like 30 different examples of how different you could make that HTML page look with just using CSS. And I want to apply the same thing for the software architecture diagrams. So here's the example I showed you before, and it's got some very boring gray boxes. This supports the concept of themes, so we add theme defaults to the bottom, and bam, we get blue boxes, different shapes now. This is also supported for things like deployment diagrams. So the C4 model also defines a deployment diagram. This is also supported by this tooling. The deployment diagram just shows you containers nested onto deployment nodes. I have created a bunch of themes that include the Amazon icon set, the Azure icon set, the GCP icon set, et cetera, et cetera. So we can turn this very boring-looking diagram into something like that just by using the pre-built themes. So this is a really nice example of how we're using the AWS icons in a much more meaningful and much more structured way, which I quite like. How do we do this? It's basically like CSS. So when you define all of your elements and relationships in the model, you can associate text-based tags with them, much like you would with HTML elements and CSS classes. And then you define a bunch of styles, one per tag, essentially. So here's a simple example again. To style this, we just add an element style for the software system tag. All of the elements get a set of default tags, so a software system element gets a software system tag, and we can change the background color, et cetera, et cetera. It's a bunch of stuff you can change. And there's support for lots of different shapes and colors and border styles, et cetera, et cetera. One of the nice things about separating content from presentation is you can change the presentation depending on your use case for these diagrams. So imagine we have this, and we want to embed it in a presentation in a PowerPoint slide, but there's lots of text. And although you want the text for sticking this diagram in Confluence, you don't necessarily want all of that detailed text when you're doing a presentation because it might be quite distracting. Well, just turn it off. So this is really, really easy to do with this tooling because you just say, I don't want to show descriptions, thank you, and it regenerates the diagram without those descriptions. That's something you can't really do in Visio without copying the whole diagram and taking all the descriptions out. And this leads me on to one of the really powerful features of all of this. This tooling is rendering tool, it's diagramming tool agnostic. So with the traditional approaches to diagrams as code like plant.uml, we're using the plant.uml DSL, the text-based format defined by the plant.uml tooling, or Mermaid, as an input to the diagram generation process. So in other words, this plant.uml code will only ever generate that one diagram. That's it. You're stuck with this tooling, you're stuck with that diagram. And if you don't like what the diagram looks like, you now have to take this and convert it to a completely different tool. With my approach, I'm using things like plant.uml and Mermaid not as input formats, but as output formats that we automatically generate during the diagram automation process. So what we can do now is this little piece of structurized DSL text can actually generate all of these different types of diagrams in different types of tools. And the different types of tools, of course, all have different trade-offs. Some are server-side rendered, some are client-side rendered, some are interactive, some are static PNG files, some are SVG files. So there's a bunch of interesting tools that you can look at with this approach. One of the things you'll see with many kind of diagrams as code tools is they prefer automatic layout, and some people really like automatic layout. I don't. I always find automatic layout kind of puts boxes in the wrong place, and I want to move them around, and you can't because you get stuck. So my preference is to use manual layout for architecture diagrams. And again, that's something that this toolset gives you. Depending on the diagram renderer that you use, you can decide whether you want to use an automatic layout tool or a manual layout tool. That's entirely up to you. In terms of manual layout tooling, I have something I created over the past couple of years called Structurizer Lite. So this is a completely free version of my Structurizer web-based browser. This is essentially a Docker container. It's on Docker Hub. You pull it down. You start it up. You point it to a folder containing your Structurizer DSL file. You go to localhost 8080 in your web browser, and it basically creates a bunch of diagrams for you on the fly. So the way many people use this tooling, of course, is they check their diagram source into source code control next to their code, along with the script to boot this thing up, and then they can view these interactive web-based, browser-based diagrams on demand. So many of the example diagrams you would have seen so far are generated with my Structurizer web-based renderer. It's interactive, it's navigatable. If you have a system context diagram, and you have a container diagram sitting underneath that software system, my tooling allows you to double-click and get to that container diagram. So it kind of implements that double-click to zoom type feature. And things like diagram keys. This is the diagram key here. This is generated completely automatically for you based upon the tags and the styles that you define as a part of your DSL definition. The Structurizer renderer also provides a force-directed graph, like a D3JS force-directed graph, which is another really interesting way to visualize those same diagrams in a visualization format that's much more concise, and I'll explain why that's a good thing later. And that's basically what you get. When you boot up Structurizer Lite, you get a nice diagram editor, and you see all your diagrams. You can zoom in, zoom out. There's support for tooltips and export to PNG and SVG, and there's a presentation mode and a whole bunch of other features you can look at. Again, that's all free. You can also embed Markdown and ASCII documentation alongside your diagrams, and actually what you can do here is you can embed the live dynamic interactive diagrams inside your Markdown and ASCII files. And the Structurizer Lite renderer will render that documentation in a nice little kind of navigatable format, and there's full text search and quick find and all that sort of stuff. I've also done the same thing for architecture decision records. If you've not looked up architecture decision records, definitely something I'd recommend teams look at. If you have a folder full of architecture decision records, you can literally point the Structurizer DSL at that folder, and it will automatically parse the ADRs and craft them into a nice sort of kind of HTML web-based microsite that you can navigate, full text search, etc. So that's one option. That's my Structurizer browser-based renderer for diagrams and Markdown ASCII documentation. But as I said, this whole tool is rendering tool agnostic. So some more stuff I built is called the Structurizer CLI, also on GitHub. It's also a bunch of Java code. This is essentially a wrapper for the DSL and the Java library, and also some exporters which are also built in Java. And what you do is you pull down the CLI, a bunch of options for how you do that. And you can run the CLI, point it to your workspace definition, and say, I would like to export all of the views defined here in Plant.uml format. It runs through, finds all the views, and creates you a bunch of, in this case, .puml files. So these are kind of native raw Plant.uml format, which you then pass through Plant.uml to create your diagrams. So this is quite nice. Now this kind of puts you back into the tool chain that you might have been using before if you're migrating from something like Plant.uml. And all the diagrams look different. So there's support out the box for Plant.uml, and that has a bunch of different shapes and things it can do. There's support for C4 Plant.uml. So the Structurizer CLI, the export functionality, will export C4 Plant.uml definitions that you can then push through Plant.uml. There's an export format for Graphiz and Dot, if that's a toolchain you like. There's also support for Mermaid. So GitHub has now supported rendering mermaid diagrams in GitHub Markdown. So you can run all this tooling, create yourself a bunch of Markdown definitions, drop those in, generate a bunch of mermaid definitions. These tool names are all complicated. Generate a bunch of mermaid definitions, drop those into Markdown, and have those rendered in GitHub. There's a really nice tool, nothing to do with me, it's called Ilograph, or Ilograph, ilograph.com. And it's a really nice, again, browser-based tool that allows you to explore and navigate a hierarchical data set. So I've created an export format for this tool. The actual data format it uses is a rather nasty-looking YAML syntax. Please don't craft that by hand. But again, you can craft up your structurized DSL, export that to Elagraph, drop it in here, and you get a nice way to navigate your software architecture model. So that's what I mean by a rendering tool independent. You can take this one definition and export it to a bunch of different formats, and then you're kind of nicely in those tool chains. And again, you can get more fancier. Some of the different rendering tools offer different shapes and stuff like that. But there's more. There's always more, isn't there? One of the big questions I get from specifically larger teams is like, well, how does this tooling, and in more general, how does your C4 model work with real systems, like big, complicated systems? Because once you start having more than maybe 12 or 15 or 20 boxes on a diagram, all of your arrows start overlapping, and it gets very, very complicated very, very quickly. So let's imagine you have some sort of service-based architecture. And maybe you have like a user using a web application, and then there's a bunch of services sitting behind your web application. Imagine this was not 4 services. Imagine this was like 40 or 400 services. This diagram is now going to start getting very, very ugly. So how do we fix this? Bunch of options. Option number 1, rather than drawing one diagram showing all 4 services, maybe we draw 4 diagrams, each showing 1 service. So maybe we can do something like this. Maybe we craft up one diagram that focuses on service 1 and things connected to and from service 1, and similarly with service 2 and 3 and 4. Do this with Visio, and of course it's hard. You have to start copying and pasting elements across all of your different diagrams. With the structurized DSL, because it's model-based, it's really simple. 4 lines of code will give you that diagram. So what we're saying here is we're saying create a container diagram for that software system, include the user, include service 1, and service 1 is the combination of the API and the data store in this case. Include things going into service 1, and things coming out of service 1, and apply automatic layout. So those 4 lines give you that diagram. So this is a really nice way to kind of slice and dice your model and create different views of that model to tell the stories that you want to tell. Because all of this stuff works before the diagram rendering stage, this is applicable to all of the export formats as well. So you craft up your DSL file, you push it through PlantUML, and you can get a kind of partition or slice diagram using the PlantUML rendering engine as well. To do service 2, you do the same thing. So this is a really nice, quick way to generate a bunch of diagrams very, very quickly. So that's kind of option 1 for dealing with really big, complicated software systems. Option 2 is to use a different visualization format, and this is why the structurizer renderer, the free Docker version, includes this force-directed graph. So this is interactive. You can click on a node and drag node around, and if you click on a node, it will show you what it's directly connected to. There's support for kind of hover over tooltips. So this is a really nice data format. It's a really nice visualization format for showing larger volumes of data where you want to maybe ask questions like, if we change service 1, what's the impact? Or you could use the Elagraph tooling. So you craft up your structurized DSL, you run the export to Elagraph, you copy-paste the massive YAML file onto the left-hand side there, and you get this really nice interactive visualization engine. If you were to click that service 2 API box, again, this is all nice and interactive, and it's kind of all zoomy and stuff, but it basically does this and kind of says, oh, you want to see service 2, boom, it kind of puts that in the middle. So again, this is a really nice visualization engine for kind of bigger, more complicated architectures. How do you do lots of systems? You know, this is great for a single team, but how do you maybe reuse some of this information across multiple teams, across multiple systems? Well, there is support for things like workspace extension. So what you can do is you can craft up a definition of all of your people and your software systems, maybe across a department in your organization, and then you can extend that definition, so you reuse the people and the software systems, but you're creating C4 model drill-down diagrams per software system that you want more detail on. So that's all something that's also supported kind of straight out of the box. Earlier last year, earlier this year, or maybe end of last year, I added support for JSR 223, the Java scripting API. So what you can do now is you can take your DSL file and you can stick in a Groovy or a Kotlin or a JRuby or a JavaScript Rhino script if you're using a VM that supports it still. You can embed a little script in there. And you're like, why? Because the DSL does lots of things for you, but there may be some features of the underlying structurizer for Java library that you can't quite get to. So you can open up a little script, and you can just do something like create me all the default views, but turn off automatic layout. You can have script inline, you can have scripts in external files. There's also support for things like plugins. So there's a little Java interface you can implement, stick that on the class path, add it to a plugins folder in this case, and you can have complete access to the underlying structurizer for Java library. You can also do things like use both. So you could use the DSL and use the underlying Java library, and you might be thinking, why? What's the point in writing actual Java code to start generating diagrams? So maybe, let's imagine we're crafting up our DSL workspace, and we're saying we've got a user using a web application. That might be the level of detail that we want to handcraft in our DSL definition. But of course, inside that web application sits a bunch of components. And maybe there are lots of components, and we don't want to handcraft the list of all of those components and the relationships between them. So maybe we have this as our DSL file, and then we write a separate Java program. We add a dependency onto the structurizer DSL parser. It's all on Maven Central, of course. We basically say parse the workspace definition, go and find the container that's named web application that sits under that software system, and now write some code to go and find components magically using introspection, reflection, source code analysis, whatever technique you want to use, and then craft up a container view showing all of that detail. So this is a really interesting way to do kind of diagrams as data. You're essentially auto-generating parts of your overall software architecture model from things like your source code, or things like your Terraform definitions, or your CloudFormation definitions, or maybe you're pointing some code at your AWS account and extracting out information about your real target deployment environment. So that's a really nice way to kind of use this in a hybrid approach. How do people use this type of tooling? To be fair, the majority of people, the majority of teams that I see using this are handcrafting DSL files. And what they're normally doing is they're drawing high-level system context diagrams and slightly more detailed container diagrams. And because this information is kind of hard to extract from a real code base, it's often easier just to handcraft these DSL definitions. So that's what I see people doing the most. Again, with the hybrid approach, with the Java library all being on Maven Central, you can do more diagrams as data type stuff. So if you have an internal data source, maybe you have an internal service catalog that has a list or is a repository of all of the systems or services that are deployed in production in your environment. Maybe you could write a parser to pull that information down and use that to craft up like a system landscape diagram. So this is, again, it's a really interesting way to start leveraging existing data sources within your organization rather than starting handcrafting the same information in a separate text file. Most people still, unfortunately, want static diagrams. They want PNG files and SVG files to stick in SharePoint and Confluence and GitHub Markdown pages. That's fine. There's a whole bunch of ways you can generate PNG and SVG files out of this toolchain with the different diagram rendering engines. I'm a big fan of interactive diagrams. I really want us to start moving away from PNG and SVG files and really using the interactive nature of the web browsers that we have. Because you can embed much more information behind that model. You can embed metadata. You can do things like views and perspectives, if you're familiar with Owen Woods and Nick Rosansky's book, Software Systems Architecture. So there's a way to kind of do those sorts of things with an interactive diagram. If you want to view your architecture model from a security perspective, you could define that security perspective on your model and then have a way to kind of filter out anything that doesn't have security information attached to it. You can do reviews on interactive diagrams. You can do presentations with interactive diagrams. You can animate some of these diagrams because they are by nature interactive. So that's, I think there's lots more interesting stuff we can do here, and especially when you have those larger models, those larger data sets, something like an interactive D3JS force-directed graph is potentially a much better approach than just using a bunch of static images in a Markdown file. Some closing thoughts to kind of wrap this up before we open for a few questions, hopefully. Diagrams as code is awesome. It's very easy for us as software developers to kind of get into. The barrier to entry is very, very low. The majority of the tooling around this is open source. PlantUML, Mermaid, Graphviz, Dot, et cetera, is all open source. These things are easy to diff, so you can include your diagrams and your documentation if you're doing things like docs as code in your pull requests. So now your pull request has your feature change, your doc change, and your diagram change. And now somebody can review that entire thing, so making sure you're keeping your diagrams and documentation up to date when you make a change. And because a lot of this is automatable, because you can install the tools on your CI/CD server, it's much easier to automatically generate these diagrams as a part of your build process. So diagrams as code is an awesome technique. My approach here, which I'm calling diagrams as code 2, which is really models as code, of course, does make this model-based. So we're now reusing elements and relationships across multiple diagrams so we get better consistency. And we're separating content from presentation through that diagram rendering tool agnostic approach, which is interesting because now it allows us to plug in our own rendering tool in the future. If there's a specific way we want to visualize our model, visualize our diagrams, we can absolutely do that, of course. The problem with general purpose diagramming tools is because you spend so long lining the boxes up, we get attached to our diagrams. And imagine you spent like 4 hours lining up your diagram elements and making all your arrows straight, and then you show it to someone, they're like, but you missed something. You're like, oh, come on. And you just don't want to change it because you've spent 4 hours making all the arrows straight, and you have to go change your diagram. I want to get us out of this mindset. For me, the diagrams are super powerful, but for me, I want to just use the diagrams as a way to tell stories and potentially just have those things as being disposable artifacts that are easy to recreate if we need them. The downside of this approach, so this is not a silver bullet, of course. The major downside of this approach is it's not very accessible to non-developers. So anything with as code in the title is going to put off non-developers. To be fair, I'm specifically targeting this tooling at developers. People say, Simon, who should be drawing architecture diagrams on a team? And my answer is it really should be the software development team. And sometimes you'll get these kind of non-coding architects who want to get into this tooling and they don't know how to do it because they're non-coding architects. This tooling is not for them. So that can put people off using it, of course. In terms of where do you keep this stuff, I would stick all of your diagrams and documentation as code next to your live production code in source code control, and then it's all in one place. And again, as I said, you can include it in your pull requests. And if you want non-developers and non-team members who need access to this stuff, well, you publish it. So you take all of your markdown files with your PNG, SVG diagrams, and you use mkdocs or Hugo to go generate a static website. Or you publish this to, so with the Structurizr Lite thing, you can run that Docker container on a CI/CD environment. So you can craft up a URL and just send people to that URL. You can kind of publish this information to that server. So there's a bunch of interesting ways you can push this information to a wider audience. People often ask me, is this tooling suitable for doing upfront design or longer-lived documentation? And my answer is, you can use it for both. But really, for me, this tooling comes into its own for longer-lived documentation. When I'm doing things like upfront design, I'm going to use a big whiteboard or a big sheet of paper because it's just a much more collaborative way to do things like pair architecting. I'm a big fan of pair architecting. So I would tend to use this tooling as a documentation toolset rather than a design toolset. But you could do if you want to. So if this sounds very interesting, I want to give that a go. If on the GitHub repo for the DSL, there's a little cookbook that I've started to write. And it basically has like a how do I create a system context view, and there's a nice little bunch of examples on there. It's all interactive. You can click on any of the diagrams on the Markdown page, and it will take you to a live version of the DSL that's kind of powering that diagram. So there's a bunch of little recipes in there for doing bits and pieces. And if you want to try this tooling out without installing anything, you can go to structurizr.com/DSL, and there's a little demo page on there. It gives you a text editor on the left. It does some basic syntax highlighting, but that's it. Don't expect auto-completion or anything like that. So some basic syntax highlighting, text on the left-hand side there. You type your text, click the render button, and then you get your diagram on the right-hand side here. You'll notice there are a bunch of tabs across the top. So this diagram here is the web-based structurizer renderer, the same one that you find in Structurizer Lite. The graph is also built on this demo page, and then you have all of the exports for PlantUML, C4 PlantUML, Mermaid, Dot, Illograph, etc. So rather than installing the CLI, you can just use this tool and grab those export formats. And that is that. Thank you very much. Obrigado.
So does anybody has a question? Please raise your hand.
Do I have integration?
Please repeat the question.
Yeah. So do I have integration with ASCII doc diagram? Kind of is the answer. So there's a bunch of tooling called Crocky, I don't know how you pronounce it. That tool set, however you pronounce it, has just added support for the structurized DSL. And it will give you, I think it's the PlantUML version of the diagrams. So kind of, there is some integration there, yes. But it's not going to give you everything you've seen here. So I think to summarize that question is like, how do you kind of better integrate this with your actual source code? You think about auto-generating diagrams from your source code, for example. So as I said before, there's a library called Structurizer for Java, which is basically sitting behind all this tooling. There's a Java extensions library that's also on GitHub. In that extensions library, there's something called a component finder. And the component finder is a way to go and find components in a production code base. How does it find components? Well, there are a bunch of different pluggable strategies you can use. So for example, if you're building a Spring app, you can basically say, go and find all of the code elements in my code base that are annotated with @controller or @repository or @component. And then the component finder will kind of find these things, figure out what's a part of those components using the typical Spring naming conventions, kind of call that thing a component, and then find relationships between components. So yeah, you could do things like this. You could integrate this tooling with your Java code base. And of course, you could build your own custom annotations to add into your production code base, and then write some tooling to go find those annotations, and then drop them into this model. So yeah, there's a bunch of tie-ins you can do here. It is going to require some effort on your behalf, though, because all code bases are different, of course.
If you have a question, please keep your hand up. Here. Come on. Wait for 5 seconds, 3 seconds. Here you go.
So on an enterprise that you have dozens of teams, dozens of repositories, from what I understood, maybe you'd use something like the extensions of Workspace and all that. But even then, I'm wondering, how does the extensions have support for, like, say, type checking or something like that, that you would know? How do they know what exists on the higher level, and how to collaborate on that, on such a big enterprise? Yeah.
Yeah. So when you're extending a workspace, you essentially get access to everything that's defined in that previous upper level workspace. And the DSL parser, when it parses the workspace, the one that you're crafting up to extend, there's lots of checking done at parse time. So it will try and find links to elements and relationships already defined, and it will know to do the right thing when you say, I would like to add containers to a software system that's already defined in my kind of super workspace. So yeah, that's kind of all built in. So it shouldn't be possible to craft up an inconsistent model when you're splitting it across multiple files. The other thing you can do is the Structurizer DSL provides support for like an exclamation mark include feature. So you can also use includes in conjunction with things like extensions if you want to achieve reuse in a slightly different way. So yeah, that's all taken care of because it's model-based. It kind of knows what's going on.
And I'm wondering, you talked also about being more dynamic, being browser-based and all that, the diagrams. Do you plan to do something like really drilling down, I don't know, having from the different levels being able to drill down between one another and all that, giving that interactivity?
So yeah, my Structurizer Lite browser-based rendering engine actually does that. So you can look at a system context diagram, and you can double-click on a system, and it will take you to the container diagram, and then you can choose a container, double-click, and it will take you to the component diagram. So that's all built into my Structurizer rendering engine. That's free, but it's not open source. If you want something that's open source, there's a project called C4Viz, V-I-Z, and that's basically a copy of my Structurizer Lite UI, except what it's doing is it's exporting diagrams to C4 plant UML format. So what you do is you boot this thing up, you point it at your workspace, it renders all the diagrams to C4 plant UML format in SVG, and then it kind of throws those at you through the browser, and it hyperlinks the various elements together on the SVG document. So you can click an element, and it takes you to the same thing. You can kind of zoom in. So C4Viz is another approach to visualizing this in an interactive way.
Okay. I think the main struggle here for me to understand is actually how so we have a bunch of different repositories that they can represent one or more systems, right? And if you are in a high-level diagram and you want to drill down to a specific container, now that documentation is in a different repository, right? So we need some kind of, I don't know, CI/CD pipeline to gather all this information to build it up together, or is there any other alternative for this?
Yeah, it's a good question, and you have a bunch of options is the kind of short answer here. So one of the things I find quite entertaining about many large organizations is they want autonomy, and they want teams to be like completely independent, yet they want a single source of all their diagrams. They want one diagram that shows like all of the teams, all the systems, and how they interact. So that's kind of an interesting conflict there, but let's assume that's what you want to do for a bunch of reasons. Option one is you pool all of the diagrams and documentation into a separate single repository. That's the simpler approach, but of course now when you're making changes to your production code base, you've now got to make sure you update the diagrams and documentation in that centralized repository. So there are some trade-offs. Option two is you craft up your landscape in a separate repository, and then so with my Structurizer Lite tooling, you can add hyperlinks to any elements. So what you can do is you can add a bunch of hyperlinks so that when you double-click, you're not taken to the next level down, you're taken to a separate workspace, maybe running on a separate version of Structurizer Lite running on a separate server. So maybe the answer here is to craft up a bunch of independent documentation and hyperlink them together via a centralized kind of map of your system. So that's another option here, and it has its own trade-offs. Because this is all automatable, you can have all the stuff in many repositories and pull it together as part of your build process.
Okay. Or we could develop a diagram discovery service.
You could absolutely do that as well. Craft up that definition into this format, and then you have access to all of the downstream rendering tools. Yeah.
Okay. If you are online, please, you are able to write down your question. I'm tracking here as well. Please, go ahead.
Just one, sorry, we're taking over this. Have you seen the need to an even higher level diagram rather than the system context? Because we have struggled with that in the past. Even there's a lot of systems in our code, in our enterprise.
Yes, absolutely. So the C4 model, although it's context, containers, components, code, there's kind of a system landscape diagram that sits on top. It's not really on top. It's really just a system context diagram with more systems and more people. So that's one of the things I see big organizations doing. They're crafting up a map of their systems and then doing individual C4 model drill downs for each system. How they come up with that landscape diagram, they're either doing what you said, so they're automatically generating it based upon system catalogs or service catalogs. So that's kind of the approach there. To kind of more fully answer the question, yes, I've seen organizations want even high levels of diagrams that focus more on business services and business capabilities. So maybe you've got like a single service capability, which is implemented by a bunch of systems. So you might want to go even one higher level up and kind of start grouping systems and show how they support that service or capability. So yeah, it's all about the level of Zoom you're interested in, essentially.
Okay, does anybody else have more questions? Please raise your hand. Okay.
One at the back there. There's lots of walking going now on the microphones.
Good morning. I had a question. Does it have any compatibility with the Xtext converted language? So Xtext grammatically made language. So I have DSL made Xtext language, and I wanted to see if I could use this tool to produce the diagrams on an IDE browser that I'm making also.
Yeah, so short answer from me, no.
Okay.
But again, so the actual data structure that sits behind this tooling is an open API. It's a JSON document, kind of JSON schema. So you could craft up your DSL and then write yourself a renderer to something like Xtext if you want to.
Okay. Thank you.
Ok, is there more questions? We should have a couple of seconds. Se você está com vergonha de falar inglês ou não fala inglês, fala em português que nós traduzimos para o inglês também, tá? É uma opção. Give once, give twice.
We've got 20 seconds, 19, 18.
We still have a couple of seconds, but here you go. Thank you, Simon.
Thank you.
That was a great
Obrigado.
presentation.
right. Hello. Welcome to our next talk here at Jnation. Thank you for coming. Thank you for having me first time in this conference. It looks amazing. I love the visual style with the steampunk and everything. I don't know if someone gave them any ideas, but okay. It works quite nicely. Okay, we're going to talk about a conspiracy today. I'm going to prove to you that DevOps is a conspiracy of system administrators and ops people against us, the developers. And I have proof. First of all, let me just check that I'm in the right place. How many of you are developers? Okay, everybody are developers. My people, great. Okay, so I don't know if you know what DevOps is. No one knows what DevOps is. People who get jobs in DevOps have no idea what DevOps is. I'm going to tell you all about it. You will know exactly what it is, why it's there, and what's going on with it, so don't worry about it. My name is Baruch. I'm the Chief Sticker Officer at JFrog. That's my official business card. I have those. This part is a sticker because sticker officer. We have a booth upstairs. Amazing t-shirts, by the way, and amazing stickers. Obviously, if you still didn't visit, come and visit us. DevOps, JFrog is a company that does tools for DevOps. This is why I got into DevOps, and this is why I can tell you all the dark secrets about DevOps. Right, so yes, I work in a DevOps company now, but if you look back, like way back, 2004, I was a developer, and you know how it works. Once a developer, always developer. This is why I'm in this conference and not in some DevOps conference, because I'm a developer, working in disguise, undercover, in DevOps company. This is what I'm doing. So, okay. Let's start building the case that DevOps is a plot of ops people. For you to really understand that, we need to look at one of the most important books in DevOps, which is called the Phoenix Project. When you want to learn about DevOps in kind of a less technical and more fun way, you read this. It's a novel, actually. It's a very lightweight non-fiction reading, fiction reading. It's not like your regular technical book. And it's fun, it's engaging, and it's a great story. I really recommend this book to start learning about DevOps. The story here is that there was a protagonist who was working in a struggling company and then kind of invented DevOps and won with DevOps. Turned the company around, propelled his career, saved the company, all thanks to DevOps. Now, to understand what this book is about, we can look at the cover and see who are the main characters in the book. So we'll start over there. Patty, she's director of IT service support. She's an ops person. And then we have Wes, director of distributed technology ops, obviously an ops person. And then we have SVP of sales. And then we have CEO. And then we have a CFO. Fine. This guy, Bill Palmer, he is the main protagonist. He's the one who invents DevOps and wins. VP of IT ops. He's an ops guy. And then we have a board member, fine, Brent. Brent, he's the most respected technical person, and he is a system administrator, ops. And then we have John, who is a security person, fine. You know who's not here? Seriously. I mean, a book about DevOps, not a single developer on the cover. Developers are mentioned in the book, not in the best of lights, I can tell you. They're pictured in people who wrote the code and then kind of don't care about anything else. They're like, done. Here's your code. Go ahead and struggle with it. And this is where, all the story of DevOps starts. After you finish the Phoenix project and you kind of figured out that developers is not a real part of it, it's all ops story, you want more proof, you go to the next book. The next book is the DevOps Handbook. They already have a second edition out. That's the cover of the first one. Doesn't really matter because the authors are the same. And what I want to talk about here are the authors. So Jin Kim. Jin Kim, we just spoke about his book, The Phoenix Project. He kind of the co-author. But there are 3 more. Let's look at those guys. Those 4 are kind of the fathers of DevOps. So when we look at their background, it will tell us a lot about where DevOps come from. Right, so Patrick Dubois, he worked as a system admin and then system architect forever. He's an ops guy, just humble. Actually, wrote a book called Continuous Delivery, one of the most important books in the ops space. And he was deputy director of delivery architecture when delivery is obviously an ops concept. He's an ops guy. John Willis, my dear friend, actually worked at a company called Ops Code, right? You cannot get any more opsy than that. He's a very ops guy. All 4 of the fathers of DevOps are all DevOps people. Now, who preaches us DevOps today? Let's look at who pushes this agenda. What is DevOps in Google? New Relic, observability platform, tool for ops. Amazon Web Services, ops platform. CollabNet, they have some developer resources, fine. The Agile admin, do. DevOps Wikipedia, fine. Atlassian, DevOps company. Microsoft Azure, delivery like cloud DevOps platform. And then towards the end, it's a Logs.io, which is observability platform. Whoever preaches DevOps to us, they're all ops companies. I think it's proven by now. When we hear about DevOps, it's all ops. The reason is what the interesting question is why. Why they push DevOps so hard? You might think it's all about, first of all, it's all about being a DevOps engineer. What is DevOps engineer? Here's a great answer for you. How do I switch my job from system admin to DevOps? Well, basically, you are an admin, and then you learn a bunch of stuff. Cloud computing, DevOps fundamentals, blah, 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 something that is called Gits. And then, boom, you are a DevOps engineer, which is nice, because you used to earn this amount of money being a system administrator, and then you switch, you learn Gits, you become DevOps engineer, and you earn this amount of money. Nice trick. You might say, hey, that's probably about that. And you know what? The demand is amazing. 1,500 jobs in the United States alone for DevOps engineer. More money, a lot of jobs, sounds like fun. And you know what? People get into this thing. Okay, we can earn money here. Let's do certifications now for DevOps engineers. Fun! More money. Well, it's not that. It's quantum entanglement. It's when we confuse the result with the cause. Money is just a result. It's not why DevOps came to be. Why DevOps came to be? Because of this. This is the DevOps infinity loop. You go from planning to coding to building, test, release, deploy, operate, monitor. Great. Now, you might see this and say, hey, this looks very familiar. Anyone has any ideas what it looks like? What it reminds you of? This. You wanted to say that? Here you go. This. It's exactly the same thing, right? We go through plan, design, develop, test, release, feedback. This is about developers. What DevOps do is say, hey, do all that, but also our part. Right? They just took what we used to do as developers and added their work and say, okay, now it's all yours. Go ahead and do it. But what they really mean is it's all ops. State of DevOps report. This is the most important research that is done in DevOps space. Every year, year after year, they ask companies about how they do DevOps, and they come with smart conclusions about what works and what doesn't, and why we need DevOps. No sarcasm, no joking. If you want to learn about DevOps, this is important. Now, this is rather old, 2018, and I look at this old report for a reason. We will get to a new edition later. Let's look what, according to State of DevOps report, is DevOps. What's it about? Aspect of software delivery performance. How do we measure successful DevOps? Deploying, taking from after the code is written to production, outages, and degraded service. It's all ops concepts. There is no developers here, nothing about actually writing code. This is a very important table, and you can see how DevOps is important because for example, elite performers spend at least double the time comparing to low performers working on what is called new work. And you can understand how new work is important because new work is where the money is. Everything else is just improving what we already have. New work is where the money is. The question is, how do they define what new work is? Types of work in the Phoenix project and in the State of DevOps report. Planned work, that's the new work. Business projects and new features. We understand that, right? This is where we write new features. The rest, internal projects, server migrations, software updates, that's not ours. Changes driven by feedback, fine. Unplanned work, support escalations and emergency outages, that's not ours. It's all ops, right? I mean, it's very interesting, it's very important. It's like we're all into that. It's just not our job. It's all ops. What is our job? We either work on new features, or we fix bugs, or we do refactoring. All these outages and server migrations and all this stuff, it's not ours. I guess you see it right by now. DevOps really is an ops concept. It came from ops people. It talks about ops concepts. It's all about ops. And the only reason it exists is to make us, the developers, work more for the sake of ops people. Nah, not the brightest idea. But let's get back to us now. What do mean for us to do our job? There are a lot of definitions, and this is one of them. It's Manifesto of Software Craftsmanship. There are a lot of questions about people who wrote it and what's not, but I think the concepts are very solid. If you look at them, not only working software, but also well-crafted software. We care about quality? Of course we do. Not only responding to change, but steadily adding value. We want to make our software better proactively? Of course we do. Not only individuals, but community. Of course, we care about that. Not only customer collaboration, but productive partnerships. I think this resonates with each and every developer in the room because this is, for us, what an excellent developer job is. This has been broke down in many conference talks, including this slide that I really like from a talk by Anton Keks called The Polyglot Developer. And this is what or a full stack developer. And this is what it means becoming a full stack developer. You need to know about technologies, you need to be a polyglot developer, you need to learn the essence of what you are doing applied to any language, you still have deep understanding in different parts of technology, you have design structure and everything. And there is an ops part into it, almost like an afterthought. It's here in the bottom, like a last bullet. And also look what's the reason behind caring about deployment, so you won't be called in the middle of the night. Not that you really care about that, you just don't want to wake up. This is all, I mean, our relations to deployment is just leave us alone. Makes sense. What do we consider done? Understand what needs to be done. Our code is readable, simple, understandable. Our code is easy to deploy. Non-functional requirements are met. We didn't incur any technical debt. Our test pass. QA took a look and they're happy. Quality is important. Team lead took a look and they're happy. And product owner took a look and they're happy. And product owner here kind of represents the customer, so we consider that the customer also is happy. Right? I guess you're with me on this? Looks good, looks comprehensive, good. All right, so I don't know if you remember, back in the day, there was like stupid notion that the developer are at war with the testers. I mean, it's ridiculous because, as we just mentioned, quality is important to us. And that means that the testers are not our enemies, but actually our friends that help us make our software better. Every time the QA finds something, it gives us the opportunity to make our software better. And that means that we love them, we embrace them, we want them to do their job because it helps our job. Sounds good? Agree? Perfect, great, okay. That means we care about quality. And that's a good thing that we care about quality. The question is what quality is. To answer this question, I want to take you back in time. This is the website of my bank 10 years ago. You can see Flash doesn't work anymore, right here, and this is fine. But all the rest actually looks like decent 10 years ago. I can log in, I can probably like see my balances and my transactions and much more and what's not, but this is pretty much it. If I want to do 10 years ago something meaningful, I take my sheet and I go to the branch because this is where I can do something meaningful. The website was nice, but it wasn't like critical. So when I see here in news and announcements that there is a maintenance window of 12 hours for software updates to ensure quality. I get it. I mean, fine, you want to do better site, it takes you 12 hours to update, fine, I don't really need your site anyway because I'm going to the branch if I need anything. Now, obviously, I know and you know that this era is gone. Last time I switched banks, it was because I didn't like the mobile app of the bank, because this is where I do my business. I don't remember last time that I went to the branch, and I have no intentions to go there for anything because everything is now online and in the apps. I really don't need it. The definition of quality changed. It was okay then, it's not okay now. That means that our quality needs to be top-notch because no one is going to tolerate those things. The problem is that it's not only about our code. Those days, to ensure quality, we need to take into account the data. And the data is going through the roof. That's a study from Seagate. They're kind of biased, but okay, you can factor in whatever their bias is. By 25, and it's like, what, 3 years away, 175 zettabytes. Petabytes are a lot, and then there is exabytes, which are like really a lot, and then there is like zettabytes, which is like fucking a lot. Like, really. And that means that we have more and more data in more and more companies that makes our testing to ensure quality harder and harder. Because remember the blissed days when we just used a staging server that looked and felt and behaved exactly as production server, and we could test anything on it, and then if it works on the staging server, we're done. It will work in the production server with exactly the same quality. Well, this means that staging server is dead. It means that we cannot test everything in staging just because it doesn't make sense. We have so much data in production that we cannot, or it's not worth it, to replicate it in staging. And you know what that means? That means that we are going to test in production. What can possibly go wrong with that? To test in production, there is now a whole new industry emerged to test in production. And this industry has a bunch of very cool terminology. All of it, it's kind of around this progressive delivery thing. Progressive delivery thing means we are going to throw untested or not completely tested software in production and see what happens. The term that I really love on this slide is blast radius. Why do I love it? Because it's on point. Blast radius is, you know what it means. You have a blast, a bomb or something, and then there is a radius in which people are dead. Blast radius in progressive delivery is exactly the same thing. You throw an untested software or less tested software to production, and then there are casualties. What progressive delivery tries to do is to minimize the blast radius. Minimize is important because it doesn't mean eliminate. People will suffer. We'll just try to make it as less people as possible to suffer, and this is why progressive delivery is important. But basically, yes, everybody admit, we are going to throw untested software to production and see what happens, expecting casualties. And that's fine with everybody. And I guess if it's fine with everybody, it's fine with us. We're now testing in production. And if we are testing in production, and follow here my train of thought, if we are testing in production, and being in production is what's needed to ensure the quality of the software, and we already established that the quality of the software is important to us as the developers, it means that now we care about what happens in production. And if we care about what happens in production, that means we have to be there when we throw untested software on unsuspecting customers in production and observe from our bunker the blast radius. We have to be there, and that means we need to be on call with the ops people in the middle of the night when things go boom, because suddenly it's not only their concern, it's our concern, because this is the first time we actually get to test our software. Fun. Now, that also means that we have to add a new item to our list. And this list is something weird. SRE took a look and they are happy. Let's unpack this thing. Who are those SRE people and what they are doing? So SRE is a term that Google came up with to give a technical meaning to this notion of DevOps. DevOps is a methodology, DevOps is like a collaborative culture, DevOps is about mindset transformation, blah, blah, blah. Where is the money? Where are the engineers come in and make things better? Here they are. Software reliability, site reliability engineer, or as they lately called, service reliability engineers, are the people who implement DevOps. They are people who are in charge of whatever happens during night when we deploy to production. So when we established that they depend now on us and they kind of give us the feedback loop of our quality, suddenly we care about what they have to say. And what does it mean? What are their requirements to our software to be successful in their job? And that means us being successful in ours. First of all, we understand how our code is going to be deployed. Why it is important? Because remember, it's 3 a.m. in the night. There are casualties out there, blast radius. We need to roll out new version of our software with fixes of our own bugs, we need to understand how it is going to be deployed to production to do it as fast as possible. The build is reliable, repeatable, and fast because we need to build 3AM reliable and fast. Our code is stateless. Well, there are opinions what scalable means. It has to be scalable anyway. Our code starts fast and dies fast. Starts fast, obviously, we just released a new version. It needs to go online as fast as possible. But also dies fast. We need to kill the buggy version as fast as possible. Our code is observable because we need to know, everybody needs to know what's going on with it so we can find the next bug and then fix it as well. Our code supports feature flags. Feature flags are nice. It's the way to turn off the buggy part of our software so no one knows it has bugs. Pretty neat. Our code backwards compatible, obviously. Now we have a new version of one microservice. It should work with the old versions of the rest of them. But also forward compatible, because now we rolled back a new version of our microservice to the old one, because the new one has bugs, but all the rest of the microservices are newer, so it has to be forward compatible. Good luck with that. And event streams are fine. Now, this is a list that you might say, oh, ops concerns. But no, they are your concerns because, to remind you, this is what you need to ensure quality for your software when it runs in production. So you care about this stuff starting like now. This looks also very familiar. There are different ways to express this list. One of them is the 12-factor app. The 12-factor app, it's another manifest that describes how cloud-native, scalable software should be written in the modern era. People implemented that, and it's the same list, and then they call it, well, that's not enough. So let's come with more factors. 16, 14, 18, whatever. For some reason, they're all even, and some of them are power of 2, but there are tons of lists that describe the same list that I just gave you. There is one more thing here. Our code is lean. Lean like in saving money. And you go like, and what? What it has to do with me? Ops spend their money on this crap. This is not what I care about, right? Wrong. Here's an example. Kafka Summit 2019, talk by Uday from Signal FX, now Splunk, about how they implemented Kafka. You all agree that Kafka is our concern. It's a framework, it's a tool that we all use as developers. And look at this. Kafka saves in cross-availability zone network costs. Kafka actually reduces the cloud bill that those guys get from Amazon every month, and implementing Kafka saves money. Now suddenly you care about money, you care about savings, you care about business. So next time your hairy-pointed boss say we need to cut costs, and the usual answers will be, let's do layoffs, or you know what, let's charge for coffee. No, we can do better. We can switch to serverless and go to cloud and save money. And by the way we write software, we can save our company money. And that's pretty awesome. So next time you're worried about layoffs and paying for coffee, instead, learn how to pronounce kubectl, which is the control command of Kubernetes, and start saving money for a company instead of the other ways of doing that. And then your hairy-pointed boss asks, we need more happy customers. Let's see what we can say there. Those are customers, and what do they want? Your customers, what do you want? New features. When do they want new features? Yesterday. How can we deliver features faster using our skills as developers? DevOps. This is a picture from the same DevOps State of DevOps report, and look what happens. Elite performance, deploy code 208 times more than the low performers. Companies that implement DevOps deploy more frequently new features to their customers, making their customers happy. And then the pointed hairy boss asks, what about security? We need to improve security. How do we do that? We have our normal way. We hire Chief Information Security Officer, so we'll have someone to blame next time we have a data leak. Or we do DevOps. What DevOps has to do with that? Here is the diagram that you might see when you apply for a driving license and learn the theory. This is stopping distance, which is built from two very different concepts. There is the thinking distance and the braking distance. They are completely different. Braking distance is physics and chemistry. It's about how well your brakes are applied to the wheel and how well the rubber applies to the pavement and how good the pavement is and everything else. Thinking distance is about, well, also kind of chemistry, but chemistry here. It's how fast the signal from your eyes that you realize that you need to brake translated to the signal to your leg that you need to apply the brakes. Those two very different things together give us one result, the stopping distance. What it has to do with security? Reactive security is exactly the same. When you have a security incident, you need to identify it as soon as possible, one type of activity, fix it as soon as possible, basically writing code, this is what we do, other type of activity, and then update the software running in production, this is a third type of activity. All three of them are critical to react as fast as possible. And you might say, well, Baruch, don't do reactive, just do proactive. Just make sure that your code is safe, which is obviously easier said than done, especially in the age of Meltdown and Spectre. Remember those? There were two pesky vulnerabilities on the CPU level, and when Meltdown was more in use because it was easier to exploit, it was also easier to patch. The problem, the long-lasting problem, is with Spectre. Spectre is nasty because Spectre is about a technique, not a particular vulnerability. The way Spectre works is it implies the speculative optimizations that the CPU is going to do by observing similar patterns in different software pieces. We analyze a lot of software, we analyze how it behaves on a CPU level, and then we can guess how your software is going to behave, because you know what? Your software is exactly like as everybody else's, unless you are a really, really shitty developer. Because best practices and design patterns are an important part of our job. And we take pride of writing out software exactly the same as the best of it, and this is where Spectre can attack. So the way to proactively protect from Spectre is writing a really, really shitty software. Unless you want to do that, there is no protection against Spectre. This is why reactive is important, and this is why you have to be able to fix as fast as possible, but also deploy as fast as possible. And this is where, 208 times more frequent code deployments means not only new features to your customers faster, but also more secure software. So what we see here is that, yes, DevOps is a plot that came from ops people and everything, but it's also an evolution. DevOps is a mean to an end, to actually many good ends. One of them is quality. We just saw how. The other is lean software. We just saw that. New features, faster deployments bring that. and security, again, you deploy faster, you're more secure. So in the end of the day, DevOps just delivers what every business needs. That means that you don't have a choice. Now when you realize that they tricked you into DevOps, it might feel uncomfortable, but it's too late for that. It's too late for that because business liked it, and that means you need to understand what that means. And that means you are in it. Now, you might say, okay, I know DevOps diagram, this is it. It's basically, this is what I do. I'm a developer, and now I need to learn to be a QA person and the ops person, and when I master all of that, I become this wonderful DevOps engineer. And you say, well, that's pretty hard because it's impossible. And I have good news for you. It is impossible. DevOps engineers, as ponies farting rainbows, do not exist. They do not exist because DevOps is about collaboration between people from different parts of our industry. And the term DevOps engineers makes as much sense as collaboration engineer, which means it doesn't make sense. It doesn't make sense because they do not exist, or the other way around. They do not exist because it doesn't make sense. Instead, what we have are T-shaped people. Not in this term, not in this sense, in other sense. T-shaped people actually means that we have something that we know really well. And that's for us writing code. We are developers. This is what we do. We need to also know about the other aspects of DevOps. We need to understand how the ops part of the house works, what deployment means, what observability means, what outages mean, how can we help. We need to understand how QA works, what types of tests exist, how do they run, what software they use. It doesn't mean that we have to become them or learn everything they do. We do need to take interest and learn this type of stuff. So how a developer can participate in DevOps? They definitely know how to pronounce kubectl. That's very important. And that makes you a little bit more of a T-shaped person. I promised you that I go back to the State of DevOps report. And this is also not the newest one. This is just 1 year after the one I told you previously. But I want to show you how this understanding that DevOps is not only ops, but the developers are into it, not only propagates for us, the developers, but also propagates for the ops people. Only a year has passed, and look how the picture changed. First of all, look who now participates in the DevOps survey. The biggest group are developers. Look how the performance metrics changed. You remember how just a year prior, everything was about after the code is written. Now, suddenly, we have an entire pillar of software development here. The penny drops that we are in that together. And the most profound kind of a proof that ops people now understand that they need developers in the picture is this book. It's called the Unicorn Project, and the same author, and you can see the same graphical language. It's actually the same story. It's a rewrite, if you wish, of the Phoenix project. Same idea. There is a person who works in a struggling company, discovers DevOps, turns the company around, and wins. But now, the main protagonist who actually discovered DevOps is Maxine, and she is a developer. Suddenly, the ops people realize that DevOps is not only about tricking the developers into doing things, it's actually about working with developers, and developers play a central role in DevOps. And getting back to this SRE thing, look what SRE really means. And that's, again official statement from Google. SRE is what you get when you treat operations as it is a software problem. Not only we are not dragged into ops concepts, it's the other way around. Ops people now have to learn how to treat hardware and operations as software. They come closer to us, to the developers. Now they need to be both ops and dev, which is obviously impossible, but they will try it, and they will become more like us. So yes, DevOps is an ops idea. There is no arguing about it. Funny story, we had our own JFrog user conference, Swamp Up, just 2 weeks ago in San Diego. And it is a DevOps conference because JFrog does DevOps tools. One of my speakers was John Willis. Same John Willis who was one of the people who were conspiring against the developers. I did this talk. He was in the crowd, sitting in the first row, and he was nodding the entire way. He was like, yes, it was a conspiracy. Yes, we tried to trick you. Yes. So I mean, I have the official approval that that's exactly what happened, and my theory is correct. But it doesn't matter. It doesn't matter because business liked it. Business liked it because it's quality, it's saving money, it's competitive advantage, and it provides security. And that means that we are in it together. But it's not as bad as it sounds because everything is code now. And obviously, we love code. We are the developers. All we need to do is follow the principles and practices, and we know how to do that. This is our life. So all in all, DevOps is more than okay. DevOps is fine. Now, we have 8.5 minutes for Q&A, and before we do that, there is someone who wants to answer a question, to ask a question. And the question of this gentleman is, what do we do next? I have an answer. We just wrote a book about it. Stephen Chin, that was here with you on the stage during the keynote, Melissa McKay, Ishel Ruiz, that you probably know, and yours truly, we wrote a book called DevOps Tools for Java Developers. This is a book for you to take what you learned today to the next stage. You remember the list that now SRE expects for you? All the answers are here. This is how you make your code to play better in this DevOps big scheme of things. And with that, now it's time for your questions. Thank you very much.
Okay, please raise your hand if you have questions. And yeah, if you are online, please put your question here where I'm able to track it down.
Okay, I stand between you and lunch, so I completely understand if what you want to do instead of wasting your time with questions is being the first in line for lunch. I get it. So no hard feelings if you don't have any questions. If you do, fire away. Okay, lunch is winning. I can see that. I get it.
Okay.
Lunch it is.
Lunch.
Let's run to the line. Thank you.
Hi, welcome everyone. Thank you for coming. So in this talk, I will be first speaking about some existing declarative clients integrations that we've had in Spring Cloud, and then I'm going to talk and show the brand new Spring Interface HTTP client. My name is Olga Maciaszek Sharma. I'm a software engineer with the Spring Cloud team. I mostly work on Spring Cloud Load Balancer, but I'm also the maintainer of Spring Cloud OpenFane, Spring Cloud Netflix, Spring Cloud Square, and I've also been doing work on Spring Cloud Contract and RSocket HTTP Bridge. By the way, if any of you has never used RSocket, please give it a try. Fantastic protocol. OK, so what is a declarative client? Let's say we have two services that need to communicate over HTTP. We have some customer service that is going to register customers, but before it does, it wants to verify whether the customer is OK, because maybe the customer is some kind of fraud. And of course, we are dividing the responsibilities, so some other service is responsible for that. We are going to be sending HTTP posts at verify, and then we will be getting some kind of response with a customer verification result. There are obviously many ways to achieve this communication. So first, not the best, is just in whichever class we have that is responsible for the business logic, we inject a REST template or any other client, we set it up, add any custom headers, set up the URI, do whatever we are doing with it within this class, and then we call the client and we receive some kind of response. This obviously is not a very clean solution. So, as we are probably communicating with this client about maybe also using other methods, and we might be communicating with some other applications also than this verification client, we would prefer to have a cleaner solution. So we are going to extract it into an interface, create a method. Now we have set parameters, set return types. It is starting to look better. Then, obviously, if we are going to use it, we need to implement it. The good part here is that we can have various implementations. So we can also be using, let's say, web client or any other client. It doesn't have to be one implementation. And depending on the situation, on the environment, on whatever is happening, we can be modifying this. And then we can do all the preliminary setup in this implementation class so it doesn't leak into our business logic. And of course, we can. This is just a sample scenario, but we could, if we are really having heavy communication with a different application, we might be having a lot of custom setup that we need to do. So we can extract it into some kind of helper methods, and it is becoming cleaner. And then, of course, we call it in our business logic class in a very similar way. We just have this call to the verify method. And what if we could just only create that interface and add some annotations that we already use and know on the server side, and have the framework or the library underneath translated into the actual HTTP client requests? Let's imagine we provide the interface, we annotate it with the elements that we are expecting. We will see this in a demo in a moment. And then the library or framework has a proxy factory that creates a proxy that underneath translates the interface calls that we are doing into actual HTTP calls. So various of you might have already used similar solutions. One of them is Fane. And as you can see, that's what you provide, just an interface with some annotations. In this case, we have request line to specify the method and the URI, and then we can pass some parameters. Fane has been very popular. It's a Java to HTTP client binder. And previously, it was part of the Spring Cloud Netflix module, and then the core part was passed over to the community, and Spring Cloud started just providing integration. And Fein supports various HTTP clients under the hood, including Apache HTTP, Apache HC5, OK HTTP. It has this good concept of contracts, which allows to support custom annotations and resolve arguments in a custom way, which is what Spring Cloud Open Fein is doing, and what we will see in a second. And it also has a broad range of encoders and decoders, including Jackson and JSON. Also, it provides support for micrometers and metrics. So, in Spring Cloud, we have this Spring Cloud Open Fein project that provides integration for it. And what it does with the Fein project, it just makes it very usable with Spring Boot applications. And it allows you to take, instead of these Fein annotations, like we've seen, request line, param, and so on, use the annotations that are generally used on server side for the Spring controllers. For example, request param and request header, and so on. And then we are also providing a host of auto-configuration for Fein-specific beans, so you just add one starter, you don't need to do anything much. And then underneath, we provide, under the hood, the support for Spring Cloud Load Balancer and Spring Cloud Circuit Breaker, and also tracing through Sleuth. And from Spring 6, Sleuth will not be anymore available. It will be moving over to Spring Observability, and everything will be set up by Spring, Spring Boot, and separate projects. So we will continue supporting this. And this is what a Fein interface client looks like. So we are using the Spring MVC annotations this time, such as post mapping and request body and request header. And then whenever we call this method, we can pass the body object and we can pass whatever header we want. And the Fein client annotation on top with the verification service, this is the service ID. This will, what it will do, it will provide load balancing for us, so we don't need to know the host. It will just communicate, for example, with a discovery service, find all the instances of a service with the ID verification service, choose one depending on the algorithm we are using, and direct the call. So, of course, this is the way we are calling it, very similar as our interface. This time we can also pass the header or whatever else we have added in the parameters. And we can see it on the demo in a moment. As you will see, we will be communicating with Eureka using load balancer underneath, using Sleuth for tracing, and doing the communication between the two services. And what is most interesting for it is that the user has to do very, very little to achieve this. So let's go to our client. Yeah, this is our Open Fein client. And we just create the interface, annotate it with whatever we need. And then we are going to add a bunch of starters. So we have the Open Fein starter, the load balancer, Sleuth, and Eureka client. And I will show you where we are calling it. This is the method. So if you later see the demo, you can go through the various implementations we've seen that are commented out here. And yeah, pretty much everything else will be done for us. So we have this running in 9081, and we have the verification service running, where I will just show you where it is communicating. So we have some kind of controller. And as you can see, it's practically copy-paste because we are using the Spring MVC annotation. So it's the same kind of method. You just copy the declaration and the annotations on the client side. It will work pretty much out of the box. And we can run a post, and it works. So this is doing a lot of things underneath without the user having to do much. And what I wanted to show you also is that we are going to have the tracing information added for these calls. Yeah, so going back to the presentation, this project is very popular. It has around 800 GitHub stars, but what is more important, it has very big number of Maven downloads. Here you have the number just for 2021. And it is popular, we think, because it has a nearly flat learning curve for any Spring MVC users, because you can just copy-paste the annotations. But over time, we have had issues with this project. First of all, request mapping annotation in controller, we would be able to use it at class level. But if we are going to use it in the client or interface level, it is causing many issues. And it has caused even a CVE. It has been something that we have been discouraging people from doing in the docs. But still, since this annotation was supported, a lot of users tried using it in this way, and it was not good. Then, also, since it is an integration for a third-party project, a lot of times we have situations when we had maintenance issues because in order to fix something, we were depending on changes in a third-party project, and we had to wait for that. And most importantly, I'd say this is the reason we are doing the changes that we are doing now, is it did not provide the non-blocking support. And without the core Fein project being re-architectured, we would not be able to provide it. So we have started doing some work on some alternatives to provide non-blocking support. There is a project called Spring Cloud Square, which has now version 0.4.1 available and released. And there we were providing support for retrofit interclients. So retrofit is very similar to Fein in the way it works. And we were providing all the support, so auto-configuration, load balancing, tracing, all the things that we provided for Open Fein. The change that we introduced was that we only here supported retrofit annotations, not anymore Spring MVC annotations, to avoid these problems that we've had, for example, with the request mapping. And this was an incubator project. We had some users. We had some issues that we were fixing. We had some PRs. Some people started using it. And also, another project that was created by Josh Long was RetroSocket, which was a similar interface client, but this time for RSocket. And we also had this as the incubator project. Let me show you a Spring Cloud Square for just a second. So again, this is just very similar. We have some loan service application where we can post at apply to try to create a loan. And this will be using a client underneath. And this is a retrofit client with Spring Cloud integration. So as you see here, we are using the retrofit annotations. So post and not post mapping, headers and not request headers, body, not request body, and then we have the retrofit client annotation. This is the one provided by us, and this will do all the auto configuration and also be responsible for the load balancing. And again, if we add the starters for load balancer, for Spring Cloud Square retrofit web client, and for OK HTTP, we will actually get all the integration done for us pretty much under the hood without us having to do anything. So yeah, the applications communicate, as you see, not much done. But going back to this, we had these two projects. So, okay, now even three, because we have the OpenFein, which is super popular, but does not provide the non-blocking support. We have Square, which is just in the incubator, still has various issues, still not that much adoption, but provides blocking support, because another thing that we have provided there is to use web client under the hood. And unlike in Fein, where a lot of re-architecting would be necessary, with retrofit, it was very easy to just swap the client underneath. And then we have RetroSocket, which is just a budding new socket for our socket interface. So we wanted to choose some way to go. And then we were starting to have this discussion with the broader Spring team about how we should approach this, because we had a lot of user demand, users were interested in this, but we didn't have a cohesive story. So we started thinking about taking these projects, so OpenFein, Spring Cloud OpenFein, Spring Cloud Square, and RetroSocket, merging them into one GitHub repository and creating one project under Spring Cloud called something like interface clients or declarative clients or whatever. But when we brought this idea to our broader team, we started thinking of whether we could, instead of providing a lot of integrations for third-party projects, maybe instead we could just start working on our own first-class solution in Spring Framework. So that would be easier for us in the sense that we would not have to depend on third-party projects for any maintenance. And also, if you look at it, the previous integrations that we had was just certain Spring Cloud components being added on top of external third-party projects. But we could provide the same integrations on top of something that we built ourselves in Spring Framework. So we have invited the broader team, and it appeared that the Spring team has already been thinking about similar approaches. So first of all, this kind of idea is not at all new in Spring Framework. There has been the remoting package that is now being removed because of outdated protocols. So these were different, old, and maybe outdated protocols, but the idea was the same. The mechanism was the same. You had an interface, you had a proxy factory, then a proxy that creates a client underneath, and there was this concept of symmetry. So the same interface could be used on server and client side. So this idea existed, and some implementations existed. It was just not very useful anymore because the protocols it employed were becoming outdated. And so, as we brought the idea to provide these integrations, we have realized that we could collaborate and create something new. And in fact, it appeared that Spring Framework 6 already had plans to create RSocket interface client on their own. Also, there was actually an issue that existed since 2014 to create HTTP interface client within Spring Framework. And it was deferred for, wait for it, Spring Cloud OpenFAIN. So why would we create something in Spring if we have this fantastic Spring Cloud integration and people are happy and it works? And it did work until we had to be able to support the non-blocking communication. So as a team, we realized that this is an opportunity to revisit how we are approaching these issues. And that actually the underlying mechanisms are not specific to Spring Cloud. And in fact, if you see the Spring Cloud Square integration, it uses web client and web client filters underneath to provide the integrations. So the cloud features are just put on top. And some issues can only really be addressed best at the core, so within the Spring Framework. Because in order to make it in such a way that we will not have all these issues that we had before, we need to rethink the programming model and consider what we need and what not. And then take decisions about what annotations make sense for us to provide and which not, instead of just copy-pasting it. For example, as we had with request mapping. So we have decided to explore this within Spring Framework 6 and started creating our own interface client. And let me take you a bit through the thought process that we had while working on it. So first we started thinking about the request mapping. Do we still want to keep it there? And then we realized that actually there's a lot of semantics inherent in request mapping that we would not be able to support on client side. For example, you can use wildcards, you can use virtually any HTTP method, and it's full openness, while for the client you need concrete things. And yeah, you need to be able to define a single request. You can use templating, but you cannot use wildcards of any kind. And also, there were some annotations for parameters, for example, that were super server specific. So we didn't want to make it all available and have the users think, oh, maybe we support this request mapping, but only without this annotation and without that, and you cannot put the wildcard, but it's all the same. No, it would be very confusing. So yeah, we didn't want to allow something like this, that you can have any HTTP method or any URL path and map one-to-n requests. Also, when you think about the method parameters, so request mapping is not just the annotation attributes, but what is important are all these method parameters. And some of them, the ones which we have in green, make a lot of sense both on client and server side. And when we thought about this, we even looked at the Java docs, and we thought, for these annotations, we don't even have to modify a whole lot in the Java doc. It just works both sides fine. There were some things which were specific, like, for example, a request attribute. So you might think that this is more server-side. However, we also use a request attribute in web client to provide hints for Spring security on which authentication method to use. And then, other than this subset, which works both sides, there were obviously some that would only make sense on the server side. So servlet request, servlet response, or model attribute would not make much sense on client side. Similarly, with the return values that we have. So some of them can be used for both clients and server, but some others, such as model or view or SSE emitter, would not make any sense for us on the client side. So we decided that instead of keeping request mapping also on the client side, we would introduce a new annotation called HTTP exchange. And we would use only a subset of parameter annotations that we would support on this side. So HTTP exchange will have the following attributes: URL, method, content type, and accept. And by the way, this all that I'm going to be showing here is already available in Spring 6 milestones. So you can go give it a try and let us know what you think and create issues if you think something should be changed, or contribute pull requests. So this is all available. And if you see this in request mapping, we had path, we also had method, and then we had produces and consumes, which are kind of reversed here. And then also, we would reuse the method parameter annotations, but only the ones that make sense for us when we are using HTTP exchange. So the ones that we do provide right now, we have URI, that you can use the annotated parameter, but you could also override it by passing this through attribute. And we also provide HTTP method that you can define, but again, dynamically, you can override it through the parameters that you are passing. We provide request headers where you can pass strings, but you can also pass maps, for example. Same with path variables. You can have objects, but you can also have maps. And when it comes to request body, you can have objects, but you can also have reactive types, so mono or flags will work. For request param, when we have a form encoded, we will create a body out of it, and otherwise we will just add segments to our URI. We also provide cookie value, and there is also a plan to support multi-part for now. And similarly with return values, also a subset of the return values that we can expect for request mapping, we will be supporting for HTTP exchange. So as you see in this call, so this is actually exactly our HTTP exchange, and here we are using a post exchange created on top of HTTP exchange. So this is pretty self-explanatory. But this is the way that this Spring interface client already looks like, and you can already give it a try. As you can see here, we are creating, again, a simple post and just passing a body. And in this scenario, we are using blocking communication. So the nice thing here is that we will support both blocking and non-blocking mode, because just only if you change the signature, you can be returning mono, and we will take care of it underneath. So with the current implementation that is available, we are always using web client. But for the scenarios where you want a blocking call, we block it for you. You don't need to be taking care of it. So often people have an issue while starting with web client and with reactive communication that they don't know how to handle and where to handle blocking. Here it is done for you if you need this, but of course we also provide reactive and async support, and also we provide stream responses via flags. Also, we provide response entity, so you will be able to get status, headers, and body out of it. But maybe you only want HTTP headers, so you can get just that. Same, if you only want to execute something and are not caring about the response, you can use void. How are we instantiating such client? So for now, what we are offering and what we will see in the demo, you need to use an HTTP service proxy factory. You create the bean yourself for now, and but as you see, it's super easy. So we just need to pass a web client adapter as an argument, and there we are passing a web client. And the web client adapter is a class that's already being provided by us. And we are doing it in this way because maybe potentially you might want to work on your own adapter instead of using web client. So it allows you to do this, and maybe in future we will even do something like this if we get requests. And then your proxy factory is created. And once it is created, you just call create client and pass the class where you have this annotated interface. So the verification service class is the interface I have with all the HTTP exchange annotations. And you get your client. We hope that in future we will be able to provide easier auto-configuration and for Spring Boot to already declare this and make it available as a bin, so the user does not have to do this. And we are also planning to provide this kind of interface client for our socket within Spring Framework 6, Milestone 5. So for Milestone 4, we already have HTTP, and with Milestone 5, we want to be providing our socket. This probably will differ underneath when it comes to how it is built under the hood, but we think also it's going to be an interesting exercise in comparing the two models, and it might allow us to see what we are lacking in any one of them. So let's see that in use. So this was our OpenFeign client, and now we are going to be using the new one. So as you have seen in the slides, it is just a very simple bean annotation that we are going to be using here. And if you are thinking what happens to the Spring Cloud integrations, Spring Cloud provides integrations already on web client level. So we have the load balancing integration for web client, we have the tracing integration for web client. So as we are going to be using web client underneath, we will be able to leverage this. And then we create our client, and like this, we get the verification service bean. So let's see where this is being used. It is being used exactly same as in the previous scenario, just to show you how easy it is to migrate if you were using OpenFeign or any other solution. And let's see the client itself. Yeah, so this is it. Obviously, as I've said, we provide the get exchange and all the other annotations that were on slides, so you can already try using it. And we have this one running under 9085. So let's try doing a bit of requests. OK, as you see, it is already done. And let's see the logs. Yeah, so as you see, we actually have the exchange function, so the web client creating and sending a post, and we are getting some kind of response, and then we are also able to get a status and also decode it. So let's take a look on how this works underneath, because as we've seen from the user perspective, it is super easy to use. You just create this one bin, and it pretty much works. So let's see what it is that is actually happening underneath. So this is our service proxy factory. And in order to create this client, we will need to extract out of this interface, we need to translate it into certain metadata that we can use for our HTTP calls underneath. So we have here, obviously, this is just something that I'm sharing with you because so you can have an opinion on how this is built and maybe also participate and create pull requests and so on. But the user doesn't really have to handle this. So what you get is the HTTP service method that will have the method, parameters, some values, and last but not least, it will have the argument resolvers. So this is actually what is responsible for translating our annotated elements into actual elements for the HTTP client calls. And as you see, we have added quite a lot of them at this point. So we can resolve all these elements. We have the URL. For example, we also had the path variable. So again, the annotation is same as the one that we were using on server side, but now we are going, as you can see, it's the same annotation, but now we are going to use it on the client side. And yeah, we have another bunch of resolvers. And whenever we want to be able to support another annotation or something else with the body or with the headers, this is where the modifications will be happening. And yes, so this is what we have so far when it comes to the interface clients. We think they're already usable, so you can take a look at the milestones, and please do, and please let us know, because you might be able to find some possible issues. And yeah, we would like to invite you to start using it and let us know what you think, and please look forward also to the RSocket client. And I think now we will have time for questions.
Okay, time for questions. So please raise your hand. And yeah, if you are online, I'm checking your question as well. So please do it.
You can also let us your observations, what you think, your experiences with previous using interface clients, why you like them, why you don't like them. Yeah.
Okay.
Feel free to
Who
let
is
us know.
using Spring in production? Okay.
Who is using Spring Cloud Open Feign or Spring Cloud Square? Okay, and who would like to use the new interface client based on what you've seen?
Okay, 1 second.
1 second, let's wait for the mic because I can't hear too much.
So, okay. We use Spring in a project, and one of the problems that we have with the web clients is handling the retries. So we have a lot of specific logic on the retries. How in the Open Fate or in the Square can we handle retries since it's only annotations?
Okay, so, well, if you are using load balancing for these calls,
Yes.
so actually load balancer handles retries for you. So both if you're using it with REST template and with Feign, this is actually already implemented. You need to add Spring retry. And if you are using web clients, we are using the reactive retries logic, and there is also, it's also implemented. You just need to turn a flag on in the documentation. You will find exactly which flag. So you can do it, and you can also already configure some things when it comes to how many times to retry, how many times to retry on the same machine, on different machine, on which kind of exceptions or status codes to retry. So this is already available.
But with Spring retry or the...
Spring retry if you're using OpenFeign or REST template, and for web client, reactive retries, and you don't actually need to add additional dependency, you just need to turn on a flag and add some configuration.
Okay, thank you.
Okay. Hands up for questions. Okay.
Hi.
Hi.
Thank you for the talk.
Thanks.
Actually, I have a couple of questions. One is, how is the interceptors interface with this client? And another is, how does it work for automatic instrumentation for end-to-end tracing?
Okay, so when it comes to the tracing, the current implementation we have with a web client underneath. So web client is instrumented. So since this is going to be used with Spring 6, because it's not available before, you don't even need to add Spring Cloud Sleuth Starter, because now all that was happening before with Sleuth has been moved over to Spring Observability. So actually Spring Boot will be setting it up for web client. And when it comes to the other question, we are actually going to be using this service method. So let's go back to where we were creating this. So I can show you. And as you see, this is where we are creating the proxy. And we have this HTTP service method interceptor that will take all the data. So the parameters, the method, the resolvers that I've been showing, this is exactly this class.
Okay, thank you.
Thank you.
Okay. Who else has question, please? Hands up. Oh, that's amazing. So next guy must be another way. So you were able to keep the volunteer working.
How do you plan to add authentication to these kind of automagic endpoints that are generated? How can I define that an endpoint needs to be authenticated and the other doesn't need?
Yeah, that should probably already be configured at web client level.
Yeah, but we can have, should we implement at least one web client per endpoint or per set of endpoints? For instance, we could have an API of users that for a get it doesn't need authentication, and for a post it does. How can we define that? We need to split that into multiple implementations in order to use multiple web clients, right?
Okay, yeah. So a lot of things you would set up obviously on the server side, and then what you would do on the client side, you would be passing specific data, so headers or cookies. So obviously you need to pass them wherever you need them. So this is exactly same as if you were using any other client. It is just only a layer on top of it to make it more readable and easier to call. But ultimately, whatever you will need to configure for the client underneath will have to work in the same way.
Okay, thank you.
Okay. Okay, we have more 12 minutes to questions, so don't be afraid to ask questions. And again, if you are online, please write down your question. I will be able to track your question. Okay, give once. Give twice. So thank you. So it was an
Thank
amazing
you. And
presentation.
please give it a try and let us know what you think. This is very important that you do this during milestones because we can still change things. So please help us. Thank you.
Okay. Oh, now I can hear myself. Well, hello, and welcome to this talk about going reactive with Helidon. We're not only going to actually go reactive, we're going to explore a little bit more. So you probably know what company I'm working for if I'm showing you this slide. So whenever you do your business decisions, please consider, if something has changed. So this is like, okay. Okay, my name is Dimitri. I work for Oracle, so you can easily find me on this address or on this Twitter. So whenever you have some questions, just tweet me or write me. I'll try to answer it as fast as I can. And I'm also from the Bulgarian Java user group, so I'm very happy to be finally on, I would say, a real event, offline event here in Coimbra, first time in Portugal, so great pleasure to be here. So we're going to explore what actually Helidon is for those of you who don't know. We will actually see this, the most powerful part of it, because on the previous Jnation, which was online a year ago, I presented the most common usage of Helidon, and now we will actually go a little bit deeper, and we will explore really like big possibilities of it. So let us actually start. So just for you who don't know, so what Helidon is, so it's a library for developing, framework for developing microservices. As Helidon, I really like his name, is called by the name of swallow. So a small bird really flying somewhere high in the clouds. Perfect name for something which is quick, maneuverable, and in the clouds. So it's makes it unique in infrastructure of Oracle is that it's open under Apache 2.0 license. So it's one of the first products of Oracle which is under this license. So it's all the code is available on GitHub, and you just go there and see. So we accept PRs, as we usually say. Build on top of Netty. Cloud native ready. That means that you don't only just serve your microservices, but you also have everything with them, like REST, metrics, health tracing, everything you really want and need. And we have one of the best in class, I would say, GraalVM native image support, because I will actually show it a little bit later. So 99% of our code is GraalVM native image friendly. And as I say, what are the numbers, just to give an impression. So we're really small, and as you see, we provide 3 ways of shipping the product. That means that you can just do normal jars, which are executable jars. You can do Helidon native image of, GraalVM native image, and there in the middle you got this native, not native, but J-Link custom image, which custom image is cool because we are modular from the very beginning, and you just throw away all the code you actually don't need, which is good. And that's why you get better startup times, less disk space usage, and as a result, it works even good. So if we take a look at the architecture of Helidon, so we are built on top of Netty, and Netty itself is asynchronous engine. And on top of it, we actually bring this Helidon Reactive or Helidon SE product, which is actually wraps Netty and provides you all you need to run your services in the clouds, and make it in a reactive way, in a completely reactive way. And on top of it, so we discussed that the connectivity, not connectivity, but portability level of Helidon will be under microprofile. So let's actually jump a little bit just to see you. And as a result, you have 2 flavors. That makes the product quite unique. So you can write a code with annotations, like guys from Spring. Just give a bunch of annotations, and it somehow with magic will work. These annotations are provided by the microprofile specification. Other way is just write pure Java and make it pure reactive. So as a result, you have a very, very small footprint. Pure Java, there's only one annotation used, which is override. So we don't use any other annotations. And this is it, actually. So 2 flavors. And if we jump into Helidon MP, it's actually based exactly on this microprofile specification, which is a set of specifications especially designed for a microprofile. So we have Ottavio here, by the way. He's very active in microprofile. So thank him for actually doing this for us. And when I say specifications, the specifications means that it's not a code, you just implement the code. And Helidon is one of those who actually implement it. So they're all designed to run in clouds, so in a distributed world of microservices. That means you have tracing, you have fault tolerance, metrics. For security, you have JOT. You can check you can also, how I say, port the configuration with config. So whenever you have like other product who is capable of microprofile, just drop in the code you have and it will run because it's standard. We even get even more than that. So it's not only microprofile that we support. So there are also a lot of Jakarta E specifications or something which runs under MP umbrella like GraphQL and LRA. Once again, that means that you just drop in this this code and it works because it's portable, because it's standard. So we really care about standard. And what makes us also quite unique is that we are able to run full CDI. We have full CDI support, and it is also done. It can be compiled to GraphVM native image. So whenever you do something in CDI, so it will be GraphVM native image friendly, so you can create it, which is cool. But once again, all of that stuff is blocking. Blocking means that you run synchronous code, and as you run synchronous code, well, the threads are blocked. So it's just blocked and it's waiting. So for that, if we go back to the slide of architecture, you see this Helidon reactive. And this Helidon reactive, for us, we even call it the danger zone, just because you get all the same functionality as you have in MP, but you have it in asynchronous reactive manner. And even more, you even get this reactive web client and DB client I'll be talking about later. So all the same stuff, but all running reactive. So as a result, the smaller memory footprint, there is no magic which is done by CDI. Just pure Java, and that's why the memory footprint, disk usage is really, really low. So we've been playing with some guys from the GraphVM native image team. We were able to establish a web service, a REST service, which has client, DB client, and web client, and it all was 10 megabytes of space actually used. The executable, pure executable, was only 10 megabytes. So awesome in this part. But as I say, going reactive with Helidon, just a small reminder of what reactive is. So once again, it's very small, and there are a bunch of talks about it, how you should do this, but just to give you an impression. So once again, as we get a lot of data, and a lot of data has to be processed, so we're trying to reuse as much as we can from every thread, actually. So for that, actually, I made a talk a few years ago about thinking async back into Java 8. So it was a talk, I think, recorded on Devox. So when we tried to actually solve the problem of this callback hell as much as possible, and we were able to actually reuse as much as we can the threads that we have. And with this completable futures and all of that stuff, we were able to really write code which was asynchronous, and this way we used a lot better the resources that we have. But as everything has evolved, so we came up to the idea of reactive computing. So, and this reactive computing came up with this paradigm that everything can be expressed as a data stream, actually, and a propagation of change. So that's why you just have arrays are like more like data, like static arrays and dynamic arrays are like more data streams. So that's why we facilitate the propagation of change as data flow. So it's I would say, a not exactly continuation, but like, a way to describe the paradigm of this programming. So it has its reactive manifesto. Everything has a manifesto right now. And once again, we all try, we have seen this picture many times. So we try to make the code responsive, resilient, message-driven, and reactive. So this way we facilitate the idea that we reuse the resources as much as we can. So the best explanation for me personally was given by Venkat Subramaniam, as he said, like we have three flows of things happening. So we have a data stream, which is actually our data. We have an error stream, where something happens. We can react on that gracefully, and we can just say, okay, so is it done or it's not done? So the data comes something just non-blocking flow of events. We have a control of what's happening there with the events, and we adequately can react on errors. So, and as a result, we come to the idea of this reactive streams. So, once again, an initiative that provides the idea of a synchronous stream processing with, once again, not blocking back pressure. So the idea of something which is non-blocking and asynchronous and provides us a back pressure so that if, for example, the consumer cannot consume anymore, he's able to tell about it. So with this paradigm, we actually came to a very, very effective processing of the data that we have. And once again, as I started from Java 8 with this completable future, in Java 9 we have these 4 APIs, flow APIs, which actually provided some kind of a combination between iterator and observer patterns with the subscriber, publisher, subscription, and processor, which stands underneath, not underneath, in between. And once again, we have something that publishes information. We have something which subscribes to this information, and processor underneath. So, and all of that, the link between publisher and subscriber, is called subscription. And this way we can organize really, really, I would say, powerful way of processing the data. So, and as a result, several engines actually appeared, and we quite good know them. So first one, RxJava, of course, Akka Streams. Spring Reactor project is very famous. Munity by Parker's guys. So I think that there were talks here as well. Even Apple joined with his service talk. But we also have our own engine, Helidon, and I'm going to tell you actually what it is and how it is, and why it's actually interesting to have really something which is so underneath everything, so is a foundation of everything. That's what. How can we achieve really big results here? So, Helidon Reactive Engine. So, as you remember this picture, we have this Helidon SE, and this Helidon SE has its own set of reactive operators. We don't use anything from outside. So, we only use this Flow API. So, we're based on this Flow API, and we can provide two main classes that help us. This is the multi and the single for streams. So what you have to do is only to include this dependency. So we are Maven Best, and you just have the engine that you can use. So if you remember Spring, the Spring itself has this Flow API, not Flow API, but Flux and Mono. We use multi and single in our constructions, and we have, as you see, just multi with multiple elements and single with one element, and as a result, we have a very big amount of our own reactive operators to actually work on the flow of the data and to transform it the way we want. So we just create, for example, a multi. We can create a processor to process it, and then we finally publish it somehow. And quite good is that we are comparing to other frameworks. We are very, very fast. So we have some GMH measurements. Helidon really provides a very fast method for that. And now, as we have this engine, by the way, we're quite proud that it was contributed by David Carnham himself. So he is the creator of the reactive paradigm, one of the fathers. So he contributed it to us. So our own reactive engine makes us really no external dependencies, just pure Java. And as a result, we have our own reactive web server. So that means that the server, once again, it's non-blocking, fully reactive, and it's pure Java. So as you see, just create a class, build it, start, and it will deliver you, it will deliver you a full power of reactive way of processing data. So just to show you a small demo, how easily you can start a Helidon SE project. So we have our own Helidon CLI. So we can just download it. It's an executable file. By the way, it's written also in Java, and it's compiled as a native image for other platforms, so only pure Java. And we do all this Helidon init. So maybe in childhood, so we created some kind of a test or something, which you answer several questions. So you just answer several questions that we want a Helidon SE Quick Start project. And we just say, what is the project name, what is the group name, what is the version, should we make a development loop so it can look up all the changes for us. And it creates us a project, so it's Quick Start SE. Because we don't have much time, I want to demonstrate you more things. We just open it. So idea, Quick Start SE. Yes, yes, okay. So a lot of things to show. And as a result, you get a fully functional project which actually works as pure Java. And it's fully reactive. So, just, I hope you can see it, or should I make it a little bit bigger? So the code, I will just make it bigger. Or, funny thing that the idea does not handle it. But it's so small that it could just have one main file, and that's it. And as you see, the server itself, it's just a single observer. So single, that means it's something that will come in the future. So it's one element that is reactive. And all the work with server is done in a reactive way. So when the server is started, then we can just accept that it started and see that yes, so this is server, it's working. If it's something is wrong, there's another flow event happening, yes? So we can just say, okay, service failed. So once again, full control and it's full reactive. So that's why we have our own this set of operators and our own set of constructions to write everything in a reactive way. Here it just sends a greetings to all of us. Very easy. One function you actually have to do is just to overwrite one function of a server interface, and you just get the request and response, and non-blocking way of serving your microservices, your actually REST endpoints. Yep. So it's so easy that I hope it will just start like a usual main file, very fast. And if we go to terminal and type something like curl, what was the last one, like greet. Of course, it's so easy, but we can just greet Portugal. It's my first time here, so we can once again query it, but out of the box you get more than that. Even if it's reactive, we can read, not read, but just get here, health. So we can read health checks and metrics. So that means that the server not only serves you some data in a asynchronous reactive way, it also serves you how its health going, what are the metrics we are reading, and it's once again, it's all fully reactive. Yes, so as you see, very fast, it starts out of the box. There is no magic that you usually get from all the CDI stuff. And it works pretty nice. I will show you, compare you a little bit later how it works with some new features that we have just added. So, as I said, very quick, very fast, and this is exactly the reactive way of doing this stuff. So once again, not going too much into details, just because we are quite limited of time, and I just wanted to show you really more things here. As I said, so with the reactive messaging, a new project was actually formed called Microprofile Reactive Messaging, as once again the idea was to reactively send and receive messages with supportive back pressure. And of course, that should have been an acknowledgement abstraction mechanism that to say, okay, is the message received or not? Should we do something with back pressure or not? And it is designed as a pipeline, so you can easily connect different APIs there. So the messages themselves are so much abstracted that they can go through absolutely different engines. Should it be Kafka, AQ, and so on and so on. So just with few annotations, you say where should the messages go. You just do like, for example, this several messages should go to something named AQ. Yes. As you say, you can do it either with reactive way, as you see here, just to publish it, or with, not exactly just publish them as a stream, or you can just do a multi of them. That means that in a reactive way, that will be consumed. You can just even use third-party APIs, which makes sense. So we just RxJava flowable, or you can even, if you have Reactor on board, you can just say flux of it. So it will all go and will be processed. The same here is about, so we just have the emitter, you emit these messages, and there should be a consumer. Consumer should be annotated just with incoming, and as the messages comes, it just somehow consumes it. We can make, yes, you can read more information about this on microprofiles. Once again, we are caring for the specifications, and if you have this, if you follow this specification, it's quite easy. So that's why I call it like 0.25 of my presentation, just to say that based on this specification, we have made our own Helidon reactive messages. So that means that based on this interface and based the way how it's formed, we have created our own implementation using exactly reactive operators that we do have in Helidon. And this way, just with one dependency, you have all this reactive engine which is on board, has no other dependencies on them, and reactive APIs to work with these messages. So we have a publisher and a subscriber, and as a how we say, a logically connector of them, we call it channel. So it's you publish a publisher as subscriber, and in the middle you can put a processor, and all of that is completely reactive. So that means that you just create a channel. You just say what the publisher is. As you say, it's reactive, so multi of something. And you just put a listener, who actually, whenever a message gets intercepted, you print it out. You can put a processor in between to process your data somehow. So for like processor, it becomes a subscriber for upstream and a publisher for downstream. So you can put as much processors if you want. So just create several channels here, get a publisher, some reactive stream of something, a processor which does uppercase, for example, and as you see, just subscriber who prints the messages. So it's very easy to create these big pipelines of reactive data processing with back pressure mechanism support. So as a result, we took the microprofile as an idea, as a specification, and we just get away all the magic that is there happening with all the CDI, with all these injections, and it's become a pure Java, I would say no magic philosophy that we use in Helidon SE. And we have different connectors, so that means that the messages themselves can go not just from the memory, you can go through Kafka, through GMS, from AQ, and actually our socket, so a special protocol designed for reactive communication. So it's all going to go in through different, I would say, medias. And once again, Helidon has full reactive support in that. Actually, before going to reactive goodies, let me show you a code. It's quite easy code. I will open an example. Once again, just the main method who has, as you say, the server start. So it starts reactively. Whenever it's OK, we print that it's OK. Whenever something is wrong, we get this exceptional channel. We say that, yes, something has failed. And now we want to transmit some messages via Kafka from one client to another and push them via WebSocket. So as you said, we create a channel to Kafka, which actually pushes the messages to Kafka. And very, very easy connector. So Kafka connector, which is set up via just a YAML file. So okay, listen to Kafka at that port. By the way, we are very grateful to IntelliJ guys that give great support for Helidon in our own tools. And we, this way, send the message to the channel, which is actually Kafka. I think that we do have some processing. Actually, no, we don't do anything like process here. We just send the message. We emit them with the emitter, and this emitter connects to Kafka and pushes the messages there. On the other side, we say that, for example, we want to push these messages to our clients via WebSocket. So we create another channel from Kafka and consume the messages from a special group ID, is here, and just push them to our clients. So it's extremely simple, but you see, just with these two abstractions, you're able to get real data streaming, I would say, engine in a fully reactive fashion. So if you don't mind, I will just run the Kafka. So you see, it's always a good idea to not update your Docker before conferences. So I hope it's ready. And now, if we go here, I will just do Java -jar target run. Just the WebSocket jar application. It starts extremely fast, and it's pure Java now. By the way, it's not even the native image. So if we put a message here and we submit, it goes through Kafka and then pushed automatically back to Helidon via WebSocket. Hello, I would say Coimbra, for example. Yes, Coimbra. I think I missed this. And as we said, yes, through Kafka it goes, the channel, just with two abstraction, everything is reactive, and the server itself works reactively, makes it very, very easy and fast. Okay. So just to give you an example, by the way, this example is completely official. You see it emits the messages. Kafka says, this is a message I just came there. It's official example. Whenever you play with Helidon, you just run the code and you have the examples available. I will switch that off because we don't want some ports to be like used sometimes. But there is one thing. So once reactive, you have to be always reactive. And you can't do synchronous code in the middle of reactive and asynchronous code. So we have provided another thing to our clients, which is called, we can consume the data from the database in a synchronous way, although the drivers themselves can be synchronous. That means that we have created a special driver, or wrapper of the driver, which actually works with the code, with the database, in a different executor and provides you a reactive way of working with the code, with all the singles, multis, and reactive operators that you've seen. So no matter what the database is, it will run in a different executor. And as it runs in a different executor, it will work reactively for you. So you work reactively with the database, although it may block somewhere in its own executor. So another way is if you not only produce data in reactive way, but if you consume data in reactive way, there's another reactive web client. So once again, it reads everything with this multis and singles. That's why you can process the data reactively. But I hope I didn't lose you, so I see only 3 people sleeping right now. Yes, reactive is cool. Reactive is interesting. The code itself, you see, it's a pure Java. It works. I'm not much into details here, just because getting too much into details, you can just simply read it in the documentation. That's not interesting. But what if we don't like this style of coding? What we want to do is just a normal Java coding, and it's typically blocking. Here comes something that you probably may heard of for the last 10 years. And it's called the Project Loom. And I'm so much happy that finally it's not just a research project about virtual threads. It's a real JAP 45, which came like about a month ago, several months ago. It's 05, yes, it's a month and a half ago. And it will finally bring it to our own and great JDK that we can use it. Not only play with it, but really use it. Maybe for now as a preview feature, but it will come to us. So what is the main idea? You know that the threads are very important and very, I would say, heavy resource. That means for every thread you have to create about 2 megabytes of information, just describing the thread, carrying all the context that actually is required to run the thread on the operation system thread. And running a lot of threads is a bad idea. So on big machines, you really can't get up to 400 threads, as far as I know. So that's why they created those virtual threads. Those virtual threads are API-wise absolutely the same as real threads, but the virtual machine takes care of actually managing them. So virtual threads are mounted over carrier threads. And if something is blocked in virtual threads, so the virtual machine understands it, and using a continuation API, which is not external, it unmounts it and puts something else to work, making room for the others, actually. Once the JVM understands that, or the scheduler understands that, okay, the virtual thread that was blocked is not blocked anymore, it will just mount it on a real thread and let him do his job. Yes, fork join is used underneath, and once again, for us, as developers, these threads are API absolutely the same wise. So currently, you can already have the access built, so you can already download the JVM with JDK with this virtual threads possibility with Project Loom on it. And once again, the threads are now not a big resource. It's not a heavy resource. You can have millions of threads. They really don't block, I would say, real threads. It's happening somewhere underneath. And what's the best part of this is the API by threads themselves. So there are just some additional methods for the executors, like you can really create virtual thread executor, or you can see if the thread is virtual or not. So, in Helidon, we understand that this is good, and only with actually one property, or actually two properties in our case, we can run our threads, the threads which care for requests, in virtual executors. So it's really, really easy. In Helidon NCA, you don't need it because it's not blocking anyway. But only with one property, you can just change everything. And as a result, we have a small demo prepared by Thomas Langer, our architect, just to demonstrate to it how it really works. So if we have two endpoints, which is slow, making long blocking call to DB or something, and quick returns immediately, and if we run them simultaneously, the long operation blocks the threads, so they will just block everything, and for quick operations there will be no resource, and they will just break with timeout. And that's quite a usual situation. So how usually people care about such an event? As we say, giving more threads is not a good idea, because you cannot extend infinite. You can rewrite everything in a reactive way. As you see, Helidon provides this possibility to you, and it's okay. It's Java. You have a little bit to break your head with these reactive operators, with these multi-singles, and so on, and you will get a better performance. Definitely you will. Or you just can switch one property and enable virtual threads, and the performance will just burn. And actually, let's see if that's true or false. So, I have created, no, not I, our colleague, Thomas Langer has created a small demo, which actually demonstrates this idea of, we have two endpoints. I will here show you blocking way of doing it. So, in microprofile, slow endpoint which just sleeps for 10 seconds, and a quick endpoint which just returns the immediate result. And we have two clients. The clients are a little bit sophisticated as they track how many requests and response there are. No need to jump into this code. Once again, main resource with slow and quick endpoints. The very same is written in Helidon Reactive Server. By the way, just take a look how small code is actually here. So you just have a web server which you build and start. So you'll just a single, you'll wait when it starts. You block here. And this server is also has just two endpoints, quick that return the result, and slow. Here's some tricks, by the way. So as we are reactive, we can't block, so we just play with one scheduled executor, and we block for a certain amount of time here in this executor. And let us actually see, if we run all this stuff, how it happens. So I will go to console, and I have created several windows for that. Let me just start it. So window group, which is for Jnation, and what we have here. So to just enable everything, we have to switch to JDK 19 everywhere. So it's my shortcut, JDK 19. We switch to JDK, which has this Loom support. JDK 19. And yes, here, JDK 19. I hope the demo goats are with me today. Just to control, we don't need this anymore. Just to control the way the code actually using Gloom or not using Gloom, we have two properties, as I said. So if we jump to the server, the Loom just says, okay, server, enable virtual thread true and enforce them, so to be sure that only virtual threads are used. And for non-Loom, we just say false, and that's it. So only with one variable, actually, we control, should we use virtual thread or should we not use virtual threads? Okay, now if we start the server, I would say first no Loom. It will start as quite a regular Helidon MP server, which is blocking, which is just a microprofile implementation. And here we will run a few JJS, a few code examples that are target for slow client. This will, not JS, but JJ, which is short for Java minus jar. It will start sending requests and responses. At the end, you see 10 requests sent and 10 responses are returned just because we are sleeping there. If we put a fast client here, so target, then what was it? Yes, quick. We will see that actually we're getting errors, which is completely expected here. So that means that the long requests are served. The quick request simply cannot, force this through this barrier of no threads left. And as you see, the result is quite nasty. Good. So this is a blocking way. So I'm just now switching it. And now the very same stuff is done with reactive. So this reactive Helidon, I was talking to you that with reactive engine and reactive messaging, reactive operators, we just run it, and suddenly you see something interesting happening. You see long threads, long polling threads are blocking, but the quick threads are still getting their response. So that means as we are not blocking, we can process much more and much better. You see 27,000 requests are being processed, while the threads are actually blocked. So as you see, just rewriting everything in reactive can change our life drastically. Yes? You see, just see it with your eyes. I'm doing a live demo here. And good. Nice. So rewriting everything with reactive, even in terms of Helidon, may actually unleash very powerful resources. Now we stop it over. But once again, we are enterprise developers. We don't like breaking our hands with reactive. Yeah. We want some magic to happen and everything suddenly to start work. Well, let's do this magic. So we will say something which just with one variable changes the executor to virtual threads. And here you can see the magic actually happened. So it's very same code in Helidon. It's absolutely the same. It's blocking code. But as we put it through virtual executor, suddenly the quick requests become like responsive. You see, just with one property, you see as the virtual machine gets warm and warm, you get better and better performance. So Loom actually changed our lives, or will change in the next release. Or at least change the life of many enterprise developers who just wanted magic, and this magic to bring a lot of productivity to them. But you still see that we were getting there 27,000 requests per second. Now we're getting less than that. So still reactive or reactive style of coding may beat, I would say, blocking way of coding and be more performant. So this is actually the live demo. I wanted to show you this. Let us stop everything. As you see, one property only switching the threads from real to virtual gave us really awesome performance. So what actually Loom help us? So it's easy to write, so you don't even probably will need to rewrite anything. Subjects may change about this performance, so it's still in progress. But performance is really close to reactive when you need to break your brains for that. But reactive is still faster, or at least to these experiments I showed you. And here we come to another thing that I wanted to show you, is that we see this potential of virtual threads, so that's why we created something we called NEMA. So it's a project to some kind of replace this netty layer that we showed you on the Helidon architecture. So we have Loom-based web server, which have all the support for HTTP, 1.2, gRPC, WebSocket, MTLS, and all of that stuff. It still has all this access log, course support, everything actually you need, with even more things coming. So OpenTelemetry is already there. Observability endpoints are already there. But the main idea is that it's fully blocking Java code. We used virtual threads, this enhanced switches, sealed classes, and logger. For us to create a server which is absolutely only JVM dependent. So that means unlike Netty, here we don't actually have anything which is specific for a platform, and we still get even better results. And this only actually works on a JVM. We don't have some kind of a platform-specific code as it's usually done in Netty. So in Netty you have a lot of magic. And yes, so that was just a little bit dive into the future. So as you see, this thing is on its way to be open sourced. So we haven't chosen a name, as you know, Nima, so it's about to be open sourced. And once again, it's a blocking implementation based on especially Loom. So we hope that Loom will come soon, and you will see. For you who wanted to try Helidon, so as you see, you have blocking way of doing things and a reactive way of doing things. You can just follow us on these links, which are Helidon project is where we publish everything. If you want to talk to us, you can use our Slack account. We publish videos, we publish articles. And yes, reactive is awesome. As you saw, as Helidon has its own reactive engine, you don't need any other dependencies. If you understand how to write the code, you'll get a lot of performance. But quite soon, for those of us who don't want blockings, don't want to rewrite our code, there is blocking. And if Project Loom comes quite soon, I believe maybe in year 2, the blocking code is also an option. So with this, actually, I wanted to say thank you for listening, and you may try it in Helidon. So Helidon is really cool because it provides you actually this playground, all in one, to play in blocking and a reactive way. So thank you very much. Yeah. Questions?
Yes, we have questions. The first one belongs to Ambus Sampath. Hopefully you say your name correctly. Is Nima open source?
As I say, it's about to be open source, so we're working hard on that. So it's going to be open source quite soon. Yep.
By the
It's
way,
in GitHub, I think.
is there somebody
Apache
with questions?
2.0 license.
Please raise your hand. Okay.
Just
please.
The microphone, yes.
She's running, so she's not reactive. Sorry for that.
If she was reactive, she would not run. She will just fly there. Yes, almost there. Thank you.
Is it?
Yes.
Thanks. So she was fast enough. I was saying that you've shown us Reactive and Loom, Project Loom, and they're both quite performant. And from my personal experience, I've already tried reactive streams. But what about debugging? What is your experience with that? Because for me, it was quite a nightmare, almost like I had a stroke trying to debug a reactive application versus a regular classical synchronous one.
Well, from my experience, debugging is not included in reactive.
That's my point.
Yes, so you just have to write correct code from the first time.
Ah.
Yes, you see, they pay us for writing correct code, not for bugs. And yes, I completely see your pain. I know what it is. Debugging is a nightmare, but it's a paradigm. So once again, You have these three streams of things happening: data control channel and error channel. If you're able to use them, like to pass your data there, good. But this is the problem of the paradigm itself, at least at my point of view. Maybe I'm wrong.
Okay. Thanks.
Okay, is there any more questions? I get another one here. Is there any plans to have support to HTTP 3?
HTTP 3 was released like, several days ago or several weeks ago.
Yes.
Yes, most of the people don't even use HTTP 2. But we are working on HTTP 3. At least we are estimating it right now. Estimating, I would say.
Okay, it's coming, so be patient. Is there any more questions for the audience? Is more questions from the internet? No?
Speechless.
Okay, if you raise your hand, it'll be so fun because she needs to run away to you.
No.
Okay, give once. Give twice. Come on, guys, we have time. No?
No, it's written. Time is up.
Okay. Thank you, everybody.
Thank
Again,
you.
Dimitri, thank you.
Yeah. Okay.
Ah, thank you so much. I have to say that's the coolest intro I have ever seen. So kudos to whoever did that. Welcome. Today we are going to talk about Quick Framework. You might be asking why another framework in this world, and I will answer all these questions. But first, let's do a bit of an introduction. So hi, I am Mishko. I'm the CTO at Builder. You might have heard of these things called Angular, AngularJS, Karma, and Clean Code Talks. And I might have had something to do with that. So that's me. A little bit of Builder.io, who I work for. So we are a visual development platform. And when I first started, I had no idea what that is either. So I'm going to give you like 30 seconds of what it is because it ties into why we're building Quick. So imagine you have a website like on the left, and the marketing department says, you know what, we have to change it to the website on the right. And so you probably have to do something along these lines. You have to change your code and be like, yeah, changed. The problem with this approach is that it never ends. Marketing will always ask for changes, 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 and changes. And so you're probably like, oh, I know what I'm going to do. I'm going to integrate a CMS system. So you might have to do something like along these lines. And you think you won, except you haven't, because the marketing is going to be like, but we want the percentage to be bold. We want 2 sales or something of that sort. And so this doesn't particularly work either. And so you can install Builder. You can cut the code out. And you can do this important thing on the bottom, which is the register component. And you can paste it into our editor. And then the marketing people can do everything by themselves without bothering you. So how does Quick come into this? Well, most of our customers are e-commerce customers, and for them, speed matters. And Quick is a new kind of framework which is focused on speed. Now, what kind of speed are we talking about? There's a lot of different kinds of speeds, and specifically the thing we care about is the startup performance, right? There is how long it takes when I click to update something, and that's important, and we think we're performant. But I would say that all frameworks are good enough at this particular category. Instead, the category we're focusing on is how long does it take from the point I visit a website until I can interact with the website on maybe a slow device or slow network or something of that lines. So Quick is really all about the time to interactive performance. Now, you might say, hey, there's already a bunch of frameworks that claim to be quick at this thing. Why do we need to have another one? And so, I'd like to take the next 45 minutes or so, and I'm going to talk to you about how Quick is different and hopefully convince you that it is something totally unique, and it's not like the other frameworks that we have today, and it solves a set of problems that the other frameworks fundamentally cannot solve. So we mentioned that we care about performance, and this one we care about the most is the make the fastest possible time to interactive, right? That's the metric. And why do we care about it? Well, turns out Google cares about it in the sense that the SEO ranking depends on your performance of the website. If you have a slow website, Google will actually rank it lower. And so if you're an e-commerce website, you probably care about this a lot. And of course, there's a lot of evidence that says quick websites actually do better conversions, better performance, and so on and so forth. And so speed is money is really what it comes down to, right? And so you would think that if you go on the internet and look at all the different e-commerce websites, you would have some really amazing time to interactive. So this is Google PageSpeed. And basically what it tells you is that pretty much all of internet is in the red. And some companies that can actually spend the money, like Amazon, can get themselves in the yellow. But pretty much nobody is in the green because it's super, super hard to get in the green. And what I find super interesting is that when your website doesn't perform well, it's a natural tendency for people to just blame the developer. Oh, clearly the developer messed up, and only if you got better developers that cared more, etc., you could do a lot better. The thing is, if there would be some examples of websites that are actually performant, I could buy that argument. But actually, when you look at the web, you'll notice that all the websites are just non-performant. And so getting a green website is kind of like a unicorn. It doesn't actually exist. Now, people have green websites as a demo website, but I'm talking about a real website that actually handles traffic, that has analytics, and so on and so forth. And I'm going to try to convince you that the problem is the amount of JavaScript was sent to the browser. So if you look at different websites and how much JavaScript over time goes in here, what you see is that our website, our JavaScript bundles are getting bigger. And it's tempting to just say like, oh, it's the same website we had 10 years ago. We're just getting worse at this. But I'm going to argue that's not the case. The websites of today are a lot more powerful than websites of 10 years ago. They're a lot more interactive. They have more capabilities. They have better insights for the companies into like what the user is doing. So really, all this JavaScript code is not just random bloat. It's actually features and behavior that is actually integral to what the website is. But this JavaScript is actually the problem because, well, browsers have this weird quirk that they're single-threaded, right? And so the fact that in recent years we get these multi-CPU processors are actually not helping here. And so this isn't the problem that's just going to go away if you just wait. We have to actually actively do something about it. Now, the thing I want to show you is we have this tool called Performance Insights, where you can type in random websites. So in this particular case, I'm going to show you Priceline.com. And what it shows you is that when you run it, it feeds it to Google PageSpeed. And Google PageSpeed returns a score for this particular website. And it said it's 36. And 36 is kind of normal for an e-commerce website. So in that sense, it's not special. And what we can do with this website is we can optimize the images and then run it again through Google PageSpeed. And in this particular case, when we optimize the images, we get the same exact score. What it means is that Priceline has done a fabulous job of optimizing their images. There is not much we can do to improve the situation. Same thing for the CSS. Is we try to optimize it, we realize we get the same exact score, which means that they've already done a fabulous job. Which means as an industry, we are pretty good at optimizing images. We're good at optimizing CSS. Notice what happens when we optimize JavaScript. Now, this is a bit of a simulation, but notice what happens. We go from 36 to 96, right? Now, this is kind of, I said, optimization, kind of a trick, because really what we're doing is we're just disabling JavaScript. We're saying, look, this exact website, if just it didn't have JavaScript, this is how fast would it be, right? And so our job is to then figure out how do we make a website which doesn't require so much JavaScript, and this is what we're going to talk about in this talk. Now, this is just top 50 e-commerce websites all across, and it's the same story, right? Optimizing images, in some websites helps a little bit, optimizing CSS helps a little bit, but gee, if we could only fix the JavaScript problem, the performance improvement we would have would be absolutely huge. So now we're talking about JavaScript. Why is this a problem? So in the single word, the problem is something we called hydration. And all existing frameworks have this particular, for lack of a better word, problem. And this problem goes like this. You're a website, and because you want to have fast visual output for the user, you pre-render the code on a server. So you have your server-side rendering or server-side generation, doesn't matter, right? You return, basically this thing allows you to return HTML to the browser. The HTML immediately shows up, and the browser needs to do something because the page isn't interactive, right? HTML is static. And so there's a piece of Bootstrap code in your website that says, great, I need to make the page interactive. And so how do I do that? Well, this is kind of the problem. This big fat arrow represents your application, right? In order for the website to become interactive, your application has to be downloaded to the client, but not just downloaded, executed on the client. And then download and execution then allows the framework to build up its state, run the renderer, and the renderer can figure out the delta between what is inside of the HTML and what is what the application says it should be. Hopefully the delta is 0. But it also gives it the listeners. And at this point, it attaches the listeners to the DOM. And at this point, we have an interactive website, right? However, all of this code right here directly impacts time to interactive, right? This is why our websites are slow, right here. All this JavaScript that has to get downloaded and executed before the page can become interactive. And so what Quick does is it says, right, we're also going to start with SSR, and we're going to, of course, have a piece of Bootstrap. But in our case, the Bootstrap is very tiny. It's about 1 kilobyte. And on a desktop machine, it takes about 1 millisecond to execute. Maybe on a phone, it will take 10 milliseconds to execute. The point is super, super cheap. But notice what happens. We completely bypass everything, and we go straight to interactive. In other words, we can make an application interactive with 1 kilobyte and about 1 millisecond of execution time. And then it's only when you interact with the application do we start downloading the actual code. Now, I want to point out that the arrow over here is a lot skinnier than the arrow over here. And that's because this fat arrow represents your whole application. This skinny arrow basically says that we know how to download just the JavaScript that you require to process that interaction and nothing else. And so what you actually end up with is a world where as you interact with the application, more and more JavaScript gets downloaded, and more of the application basically comes to the client. So it's very interactive. Now let me show you what the end result of this is. So this is our homepage. This was built using both React Next.js and using Quick. And when it's colorful, it basically means JavaScript is running. And when it turns gray, that means that all of the JavaScript has finished executing. Notice the difference in performance. We're talking about 1.9 seconds versus 8.1 seconds on a simulated mobile device. That's just a huge difference in performance that you could get if you can do this correct. Before I jump into demos, I want to take a little detour and talk about PartyTown, and I'm going to show you some cool demos that are actually going to demonstrate everything we've been talking about. So what is PartyTown? Well, we're really focusing on JavaScript. We're focusing on the problem that, hey, there's just too much JavaScript in your application, and by removing the JavaScript, we can solve the problem, right? Turns out there are two kinds of JavaScript on your website, right? There is your first-party code that you wrote using some kind of a framework, either React, Angular, Vue, Svelte, whatever you chose. And there is third-party code that you kind of need for your application. And third-party code, it would be things like Google Analytics, Facebook Pixel, HubSpot, Intercom, and so on and so forth. Typical website has as many as 20 plus third-party scripts on their page, right? And what all of these third-party scripts do is that they eagerly download and initialize. And because JavaScript is single-threaded, it creates congestion, right? That the amount of code that you require for your application is basically drowned out by the third-party scripts. And so in real world, in production, even if you manage to somehow build a site that gets 100 out of 100 for the basic thing, the moment you start adding third-party scripts, you will destroy your performance. And of course, if you go to the marketing people and say, hey, we don't need these things, you're going to be shut down saying, well, actually we do. We need to know who's using it, how's using it, and so on and so forth, right? And so what PartyTown does is it can do this magical trick that it moves all the third-party scripts into the web worker and execute it on a separate CPU core so that your main thread is left for the application for itself. So anyways, this is a separate project that we're doing, so this is just kind of a, there's really no reason why you shouldn't integrate PartyTown to your website, so go check it out. Anyways, enough of me talking. Let's show some demos. And how's the font? Is that good? OK, and I'm going to make this font even bigger. OK, so let's start with the simplest possible hello world. And I think an important part when you get started is to talk about what the developer experience is. If you come from the world of React, Quick is very, very similar. And this is no accident. This is not accidental. We specifically looked at it and say, how can we make the DX most familiar to most people, right? And so if you look at what a Hello World component would look like, this is very, very similar to what you would see in other frameworks. The only thing that's different is this component. And there's this magical $sign in there. And I'm going to explain the $sign in a second. But in here, you just return your JSX. And if you look at the resulting HTML, you'll see that the HTML that came from the server just contains all the parts. That in itself is not interesting. What is interesting is that if you look at the network tab, you will see that the network tab is empty. Specifically, I'm filtering for JavaScript code. And so no JavaScript is downloaded, right? And so what Quick is a framework that doesn't concern itself with just rendering, but really concerns itself with the whole pipeline, right? It's not about just like, hey, I render, I'm done. It's also about like, how do I bundle this? How do I figure out what code to send to the client? How do I execute the code? How do I bootstrap the code? And all of these things cohesively together are put together. And in this particular case, Quick basically said, no JavaScript is needed and nothing got sent over here. So that in itself is not interesting. Any framework can basically not send JavaScript. So let's do a little more complicated example. So here we have a counter. Again, notice no JavaScript, but I can interact with the counter. If I click on it, the count goes up. And if you notice, when I did that, code got downloaded. Let me refresh this again. Notice what's happening in the network tab. Me clicking on a count downloads the code. Now, what kind of code? How does the system know to download the code, I guess, would be the question you should be asking. And so let's look into that. So let's look at the click. And what you'll see, and I'll refresh this one more time. What you see here is that you have a button. And a button has an attribute on it that says, what should happen? Where should I get the code if I interact with this button, right? So in this particular case, we're saying if a click happens, this is where you go and download the URL. The URL is very long because this is in dev mode, and so we're not making it short. And also, this is the symbol that the URL exports that you have to execute. And then I will explain this magical 0 on the end in a second. And this basically is the counter. So let's look at the source code. What does this look like? Again, something that should be pretty straightforward. We declare a counter. We declare a component, $, and I'll explain $, in a second. We're going to declare our state, which is very similar to use state. So we have a store. We're saying we have a count of 0, and we will print the count. And we have a onClick, again, $, and we say, well, if you click on this, you should increment the count. Now, what's up with all the $signs? Every time you see a $sign in the source code, it's a hint both to the optimizer, which is the quick, and also to the human. What it says is that, hey, over here is a asynchronous boundary. The code that is behind the $sign will be lazy loaded. So just keep that in mind as a developer, right? So whenever you see a $sign, that's a potential place where a lazy loaded code can exist, and also a potential place where the system can tree shake a piece of code saying like, actually, I don't need it. For whatever reason, I decided that I don't need the click, I don't need it. So if you look at the network tab, when we first click on the button, the first piece of code that gets downloaded is this bit over right here, which is basically the onClick, right? So the onClick says take store count ++. But there is a little bit more stuff in there. And so I want to kind of explain what actually is happening, right? So what the optimizer does is it says, great, I see a $sign over here, so I'm going to take this piece of code and I'm going to delete it, and I'm going to replace it with a constant. And I will basically pull this constant out into a separate file that I'm going to export, right? So this thing matches this piece of code over here. But notice what's happening. The store was a closure which captured the store, right? And so now the system is like, hey, I don't know what store is. In other words, closures are the things that make writing code convenient, but it's also the thing that makes lazy loading code essentially impossible. And so how do we solve this? So what we do is, we do a little bit of magic here, where we insert this use lexical scope, and this lexical scope basically say, go and restore the store property or the store state or the store object before I use it so that I can do store count ++ on us, right? And so every time, let me just, that's the wrong button, Okay, every time you see a $sign, basically the optimizer breaks your code up, puts it in the separate files, and then glues it together. So let's look at the application again. One of the things you will see is that, again, our button has this, but also we have this script tag right here that contains the state of the application. So the state of the application executed on a server, we knew that the state of the server was count is 0, and this bracket 0 basically is information to the framework to basically restore using the use lexical scope method to restore the state of the system, right? So the magical part of Quick is that we know how to take closures and serialize them. Now this is new because we know how to serialize code in the form of JavaScript, but a function in the form of JavaScript has amnesia. When you call that function, it doesn't know what state it is, right? So if you click a button that says add 1, the function will be like add 1 to what initial value? And so the magical part here is that we can store both the behavior, which is the function, and also the state of the the system. And so that's basically how kind of quick works. So let's do a more complicated example. So in this particular example, there is multiple components on a page, right? Quick was just a single component with a button, etc. Let's do something more interesting and see what happens. So here we have a component called reactivity. We create a store which has both count and debounced count. So what is a debounced count? Well, there is a watch that basically says, pay attention to count. If the count changes, I want to know about it. And so when the count changes, go print count changed, and set a timer for 2 seconds, and then copy the count into the debounce count. In other words, the debounce count is always kind of like 2 seconds behind what the count is. Once we have this, we basically have our code. Here is our button that says, if you click on it, go increment the count. And then we have a child component, and in the child component, we pass the store down to the child component, and the child component just prints out, hey, I'm printing the child component, and it also prints out the current count, and then it has a grandchild component, which again, we pass the state down, and the grandchild component prints, the grandchild render, and it prints the debounced value. So if I click here, 2 seconds later, the debounced value updates, right? So there's this delay that's happening in here. The second thing is happening here, we no longer have a single component, we have 3 components. So let's just refresh this, and let's clear the screen here. I'm gonna refresh this, and the code executed on a server here, right? And so we see that it says reactivity renders, count change, child and grandchild. So just kind of for a refresher, we go to reactivity, we execute the function that returns our JSX, right? So it says reactivity renders. Then the framework realizes that the watch has changed, so the console log count changed, updates over here. Oops. And then we go to our child component. Child component says, I am being rendered. And finally, we go to grandchild component. The grandchild component says, I am being rendered, right? So the fact that the server does this pre-rendering, that kind of makes sense. So if you go to the client and we look at the console, obviously, nothing's being printed to the console because we haven't interacted with it yet. And just like in the other cases, if you look at the network tab, nothing is in there. Now, let me click plus. Notice a bunch of code downloads. 2 seconds later, more code downloads, right? Because the update happened with a delay. Let's again go to the console. Let me refresh to clear it. Bunch of things changed. 2 seconds later, grandchild updates. The thing that you will not see over here is that the system realized actually the reactive component right here, the stop level component here, the system realized, oh, this is actually static. At no point will this component ever change, and so that function actually doesn't execute. Right? We are able to look at the graph of components, and we understand which components change and which don't, and then just don't download the JavaScript for it, and also don't execute that particular component. So we are pruning the tree of all the possible components that actually can execute. Now, let me show you how this actually works. So let's go to an intermediary component called child, and, child is right here. And the child displays the current count. So what we're going to do is we're going to say something like ignore. And so because of how JavaScript works, this ignore basically makes sure that this piece of code never, ever executes, right? So if you refresh the page, you're going to see that it says ignored, and debounce is 0. The code is not here. If I hit plus, the count has changed. 2 seconds later, the grandchild updates, but notice what's no longer there. The child did not re-render. Because the system understands, well, when I change the count, I don't actually need to re-render this particular component, right? So as a developer, you just build your application as you normally would, and the system looks at it, this information, and based on how the components update, we can figure this out. Now, at this point, you might be wondering, like, well, how does this magic actually work? What's happening actually here is that useStore creates a proxy. And that proxy contains getters and setters, and so we can notice when you go and execute props state count. And therefore, we know you're creating a subscription. We know that when the count changes, we have to re-render this component. And by essentially short-circuiting this read, we have prevented the read from happening, and we have prevented the code from updating. And so now we know that the code doesn't have to update. The second thing we do is when the application executes, we serialize all this information inside of the HTML. And because the state of the system is serialized, this is why we talk about quick applications being resumable. They run on a server, and when they finish running on the server, we serialize everything we know about them. Location of listeners, the state of the application. We serialize subscriptions, who cares about what. And the subscription is needed because we need to be able to wake up components when things change. And when all this information is serialized, what we can do on the client is we can just continue execution where the server left off, right? So normal applications, they have to download all the code and execute it in order to figure out where the listeners are and then kind of build up internal state of the framework, whereas Quick doesn't have to do any of that stuff. It can literally just continue where the server left off. And I'll show you a cool demo of that in a bit. But all kinds of new things become possible if you think about it in this particular way. My favorite demo is actually this clock demo. What this shows is, we generate a list over here so that the clock itself is below the fold. And then this just shows the clock. But let me refresh this one more time and look at the network tab. And so the network tab again shows no JavaScript present. When I scroll it into the view, it downloads a piece of code to update the clock every 1 second. And it also downloads the JSX, which is the how do you kind of re-render the particular component. And what I find very cool is that if I go and look at the HTML, you can see the HTML updates every 1 second, right? But let me scroll to the top, let me refresh the page. Notice, no updates are happening, right? So the code isn't even present, and then once the component scrolls into the view, bam, we reload the code, we start executing the behavior, and we make the component actually work. And I think that's how frameworks should work. Like, people have been talking about this idea of like, well, this component is off screen, why are you executing it? You don't have to. It turns out it's actually very, very difficult with traditional frameworks, because traditional frameworks can't really reason about the components independently. They always reason about the whole tree of components, and they always render the whole tree of components. They always update the whole tree of components, and they require that the whole tree of components gets downloaded eagerly. And so this kind of thing would be actually extremely difficult to do with your favorite framework. And I actually invite you as a mental exercise to think about it, like, what would you have to do in order to make this happen? And of course, you might be asking yourself, well, great, that's super cool. What does it look like? So let's look at clock. So clock application, we just start with making an array of 40 items. This whole thing is here just so we can create a bunch of stuff so we can push the clock below the fold, right? So this top component really is static component. And the framework knows that it's static component and won't download it to the client. And on the bottom, we just say clock. This is our clock component. And what the clock component says, well, I need you to download some styles. And notice the $, which means the whole thing is lazy. I'm going to have a state. So these are a minute and second. And I'm going to store it as the degrees, the angle of each of these hands. And I'm going to have a use client effect. And use client effect basically has an update function, which will read the current time and update the second, minute, hour. And I will basically execute this function every 1 second. Now, because this is a use client effect, the system knows that this doesn't run on the server. This only has to run on the client. And because it's an effect, we have to kind of eagerly wake it up. And so the question becomes, when should it be woken up? And the default behavior of use client effect is to actually wake it up when the component becomes visible. And so you can pass a second argument here and change the behavior in here, but the default is just do it when it's visible. And so what you get is this beautiful thing where, like, hey, the code is not needed, it's not downloaded, I scrolled it into the view, now I'm going to download the code, execute it, etc., to make all the right stuff works. So that's my favorite demo. But let's go further. Every demo has to have a Hacker News, and so the thing I'm kind of demonstrating here is that Hacker News has to go and talk to some fetch API or REST API, right, where it gets back a JSON saying what are all the stories and so on and so forth. And these stories have to be data bound to the components. And so as we're data binding the components, remember we have these proxies and we figure out what is what in terms of subscription. And so you might get to the situation, because we have to serialize the state of the system, we can get in a situation where we actually serialize the whole JSON from the server. But notice what we serialized in here. If you look at the script tag, actually it says nothing. Basically, even though we were talking to the server, even though we got a whole bunch of data, the system was able to recognize the fact is that all of that data is static. You can't actually edit it. There isn't a button present on this page which would allow you to edit this particular data. And this data is only data bound to components that themselves don't re-render. And as a result, the system was like, you know what? This data, I don't need to send it to the server, to the client. And so it gets tree shaken away. So not only is Quick tree shaking the behavior, it's also tree shaking the data that's coming to the client. And let me show you how this actually works when you go to a comment. So let's open up one of these items. We go to the comment, and one of these things that the comments, well, let me before I go here, let me just show you that the landing page and the internet is slow. Okay, never mind. What I wanted to show you is, oh, okay, now it's working. No. Here's the page. One of the things I wanted to point out is, because there is no kind of behavior on this page, no matter what you do here, at no point will you actually download any sort of JavaScript, right? So again, this is a situation where the framework can just correctly deduce, like, hey, nothing to be done over here, no JavaScript gets downloaded, and so you know, it's a static page. In this particular case, we have this button here, and so clicking on this has to download a bunch of JavaScript to kind of collapse it. And so you can see that now it says 6 replies collapse. If I open it up, it goes back to the previous state and so on and so forth, right? So this actually changes. The first page never changed. There's nothing you could do to change it. The second page actually changes. But if I refresh it, you're going to notice that the only data that got serialized is the state of whether or not this particular component is opened or not. What we didn't serialize is the actual comments. And again, this is Quick looking at the graph of relationships of which component cares about which data, and you know, what interaction needs what data to update which component, and realizing that there isn't any interaction that the user can do that would possibly cause a component that contains the data binding to wake up. And because that component will never wake up, there is no need to send the data associated with that component. And so it's a tree shaking not just on kind of the behavior level, but also on the data level. All right, and so every framework demo also has to have a to-do application. So this is a to-do application, and I'm sure you've seen this before, and the cool thing to talk about is the network tab. And you know, when I start typing, code has to get downloaded. When I hit enter, more code downloads. And as I interact with the application, I'm continuously downloading more and more code. More and more behavior is coming to the page, right? And again, this is very different from the way normal applications work. Now, I want to point out something unique, which I think kind of demonstrate this. In a normal application, there is really one entry point. There is one way that an application can get bootstrapped, right? You have your essentially your main method. And then the bundlers kind of make your bundle, and they can't really break the bundle in any other way. Like, once you refer to the root component refers to its children. And those children refer to their children, and those children to their children, and so on and so forth. And those components refer to their closures associated with the listeners, which in turn refer to other things. And so if you have a normal system, there isn't any way by which you can break it up into other things. The only way you can break your bundle up is by you, as a developer, manually introducing a dynamic import. But this is very different from Quick, because really the only thing you have to do in Quick is put a single character, the $, right? And the $, internally will move things around so that it creates a dynamic import. And so it's a lot less work. The other problem with dynamic imports is that as a developer, you need to figure out like where to put them. And this is not an easy thing to figure out because, well, the framework you're using is synchronous, whereas dynamic imports is asynchronous, returns a promise. And so you can't just like randomly place it inside of your code because That just doesn't work because the framework expects synchronous responses. So this breaking things up is hard, and the reason why you need it is because when I start typing here, I download this particular file, which is header component fragment input unkey up. And if I refresh this and I click maybe on this button, I have a completely different file which I'm downloading. The thing to understand is you don't have a single entry point to your system. You have many, many different entry points to the system. How many? Well, it turns out as many entry points as there are listeners that exist on the particular page, right? So one of the trickiest or the hardest or the thing that is the most differentiated about Quick is the fact that you can write your code as you normally would. And Quick can take that code and break it up into lots and lots of entry points. And these entry points are important because it's the way how we can say like, oh, I need that button's behavior, but not that button's behavior, right? And normally, breaking this stuff up like that is essentially impossible. Now, here's another demo that I want to show, which I think is very cool. You have your application, and we serialize the state of the application in here. And so when you type a new item like new item, notice the script tag disappeared. Let me show this again. See the script tag? When I start typing, basically when I start interacting with the Quick application has to figure out kind of the state of the system so that it can resume where the server left over. And that state is serialized inside of that JSON. So we just do JSON.parse, and then we can just continue running from where the server left over. And so we can go and change the application. Now, the cool thing we can do is we can go and grab what we call a container. And so the other thing you have to see is that this container says that it's currently resumed. Let me run it again. It's showing it that the application is currently paused. It's not running. That's why we have our script tag. And when I start interacting with it, notice it changed its state into resumed. So what I can do is I can pause the application again. And so I can do that by quick.pause. And when I do that, notice it changed back to pause, and it took the script tag and it put it back in there. Basically, it took the state of the application and put it back inside of the HTML. Now, the thing we can do now is we can just copy these HTML. And let's go to a new tab. Completely different page, right? Inspect, and we can grab the HTML over here. We can go edit. And I'm going to delete the HTML that's present, and I'm going to paste the HTML from the other side. Now, pasting HTML, the fact that the application or the page kind of refreshes, that in itself is not surprising. Like, of course it refreshes, I just pasted the HTML. But the question is, will you be able to interact with the application? Now, on any other framework, the answer would be, nope, you can't do that, right? Because the framework has been kind of, the whole state of the thing has been destroyed. But in Quick, yeah, you can continue interact with it. You can click on it, check it, and it's continuing where the server left over. And so you might say, well, that's kind of cute. Like, why would you care about this? Well, this capability is actually how we get from the server to the client. We can run the application on the server, and at any point we can pause it, which serializes its state into HTML, ship the HTML anywhere we want, and resume, meaning continue running where you left over. And of course, this trick can be done as many times as you want. And so one useful thing would be, for example, imagine you have something like VS Code. VS Code is actually just a JavaScript application, right? Wouldn't it be nice if when you close the VS Code would just like pause it, serialize the HTML that exists in the system, and when you come back, it would just put the HTML back in and resume where you left off, right? So if you have PWL application, this might be a nice way of saying, oh, the application is getting closed. I'm just going to take the HTML, put it inside of IndexedDB, and then I can resume it and continue running from where I've left over. So I think this is a kind of a pretty cool demo, and I think it really demonstrates what we mean when we say resumability. And it is clearly something completely different from hydration, which is what other frameworks do. Nope, let me go back here. Okay, we talked about to-do. So I wanted to talk about a little bit about how existing frameworks work, because I think it really kind of paints the difference in the terms of pictures. So existing frameworks are what I call monoliths. What I mean by that is that you server-side render the page, and that's shown here as gray boxes, right? Your HTML is sent to the client, and the user sees the application, but they can't interact with it because there's no listeners attached to anywhere. And so hydration is really this super expensive process by which the framework reruns the application in order to figure out where the listeners are, right? So what that means is the server sends HTML. The next thing browser has to do is to download the JavaScript. And once it downloads the JavaScript, it can go and reconcile the JavaScript against the HTML. And that's what turns the components blue. We say they're hydrated. Now, at this point, I want to point out something important, which is people might say like, oh, I'm going to be smart, and I'm going to lazy load the component, and that's how I'm going to break my large application into small applications. Well, guess what? If that component is currently on the rendered page, it doesn't matter. You have to go grab its JavaScript code, and you have to hydrate itself as well. In other words, current frameworks can only lazy load components that are not currently visible in the page. If the component is visible, it has to be downloaded and eagerly executed so that the hydration code can execute and recover the listeners for this particular component. So this is kind of how standard applications work. And there's a new kid on the block called Astro. And what Astro says is like, you know what? How about we take this big application, which is expensive to hydrate, and we turn it into smaller applications. So if I click on just this portion of the page, then only this portion of the page hydrates. And so this is known as islands inside of Astro, and it greatly improves the situation because instead of hydrating this huge app, you now have smaller chunks to hydrate, and that's better. But it creates a new problem, which is that frameworks, one of the things that frameworks do is they solve the inter-component communication problem, right? Like how do components talk to each other? How do they pass data? How do they wake each other up? How do I know that this thing has to be re-rendered? And with Astro, that particular problem is not solved because if this particular component said that I actually have to update this guy over here, that's up to you. Astro doesn't solve that for you. So the whole inter-application communication becomes unsolved. And so now we come to Quick. And Quick is unique in the sense that if I interact with a particular component, just that component gets awoken. And doesn't even make sense to talk about hydration because like there is no listeners that are being attached. The listeners are already there in the form of attributes inside of HTML. So waking a component up really just means deserializing its state, and that's just JSON parse, which is unbelievably cheap. Yeah, compared to downloading and executing JavaScript, JSON.parse is a freebie. It doesn't even cost anything. And so the other thing I want to point out is that when I interacted with a component, it didn't force me to wake up the parent components or the child components. And this is important because if you have a component, typically component has props, right? Typically component has things that the parent component has given it. And so you can't just go to React or Angular or somebody and say, like, go render this component in isolation because the component has a bunch of properties that got passed from the parent. And the same thing happens with the children. There is no easy way to go to the framework and say, A, don't render the children, but B, more importantly, don't even download the children. Because when a parent component refers to a child component, it refers to it as an import. And therefore, the moment you load a particular component, you're automatically loading all of its children to go with it, right? So the thing to figure out is not just how to isolate it from the point of view of execution, but you also have to figure out how to isolate it from the point of view of a lazy loading of the bundlers. And so, of course, Quick has reactivity. So if I interact with this component over here, not only is this component woken up, it also understands that I have changed data that causes this other component to also be downloaded and re-rendered, right? And so Quick is very surgical about what kind of code it downloads and when it downloads it. Now, I've been talking about a bunch of these applications, and I wanted to show you that actually these are not separate applications that I've been working with. This actually is one big application that I have put together. So here is all of these components we've been talking about. Here's our hello world, which is static. Here's our simple counter, React counter. Here's our to-do app. Here's our clock. All of these components are actually part of a single application. And notice the same property actually just happens. So if I am here, I look at the network tab, nothing is in the network tab until I scroll to the clock got woken up. I start clicking on the click button. That's when the code for the click button shows up. I can click on the debounce thing, and with a 2-second delay, more code shows up. And here's our to-do app, and I can add stuff to it. And again, as I interact with it, more and more code is showing up to the system. So the whole thing works on basically any page you have. And the thing that we're going after is to just be able to lazy load the whole thing. Now, at this point, you might say, like, yeah, but like I go to a web page, and then of course, what happens when there is, the internet goes down, or when I click the first button, isn't it annoying and a slow system that it would have to take forever to download? Well, I was showing you demos, and because it's a demo, we disabled the prefetching. But in the real system, what actually happens when we render the code, we know which components exist where, and we know where the listeners are, and we know all the possible things you can do as a developer. And so we automatically inject a bunch of prefetch links to your system so that the application downloads. Now, at this point, you might say, like, well, I'm just downloading an application. Isn't this any different from downloading a regular application? And the answer is no, for two reasons. Even if you download all the JavaScript code that you would download in a normal application, you've actually saved yourself the cost of executing the code, right? So the first benefit you have is that even if you download all the same amount of code, you don't have to execute it. So right there, huge savings. But the code that's here is already tree shaken, right? This code has already gone through the system, and the framework realized there's a whole bunch of static components that will never ever re-render on the client, and therefore there's no need to ship their code to the client. And so what you see over here is a pruned list of things that are actually interactive on a page, right? So you have two savings. One is less code is getting shipped, and the code is actually not executing, but it gets better. Because we have this list, and because we know how people actually interact with the application, we can keep statistical information as to what is the most likely thing that you as a user will click on the website. And as a result, we can prioritize this list. We can send this list in the order of what we think is most likely thing that the user clicks on. So even if you're on a super slow site, but you think you're going to click the buy button, we can send you the code for the buy button first, and only later we send you the code for the logout, because nobody ever clicks out the logout button, right? But we can do these kinds of tricks. And again, these are the kind of tricks that are really not possible with existing frameworks. I'm going to pause here. And I'm going to invite you to ask questions. And I assume there's a mic that goes around. Nobody. Yes. The nice gentleman that was borrowing the dongle for me.
Hey there.
Hi.
So my question is, since, we are prefetching the JavaScript and whatsoever, but we are not executing it, how does it guarantee that we are not, for instance, replacing the downloaded JavaScript with some malicious stuff?
Oh, so all of these things that you can see over here are generated by Quick. So remember, most frameworks care about how do I render? And that's where their interest ends. And what makes Quick unique, and the reason why Quick can do all of this crazy magic, is because Quick doesn't just care about execution on a client, it also cares about execution on a server, and it also cares about bundling, it also cares about how do I break the code up into pieces. All of these things are the domain of the framework, right? And as a result, what you see over here are very specific URLs with hashes incorporated in them that the Quick controls. So it's not like you can just modify these particular things. Quick won't allow you to do that.
Okay, thank you so much.
So if you have a question, please raise your hand.
Anything online?
No.
Well, I hope you enjoyed it. I will be probably hanging out over here somewhere, probably in front of the door. So if you have further questions, please stop by, ask them. And I love chatting about this and demonstrating the differences. Hope you enjoyed it.
All right, what a great intro. Hey, welcome. I just want to make clear that it's just me between you and the beers or the drinks, right? So great that you came to this last session of the day. Did you have a great Jnation so far? All right, like that, like that. Okay, cool, cool. My name is Sven. I work for a small startup called Manfred. Basically, we're doing kind of recruiting, but we're turning the recruiting process a little bit upside down. And so actually, we help developers so companies can apply to them instead of you applying to companies. As I said, we're a small startup very successful in Spain right now, and we're looking to expanding to other regions. That's just the story here. So, effective software developers. I've been talking to a lot of software developers. I've been working for companies like Atlassian and MongoDB. So I talk to a lot of senior and junior developers, and just like trying to find like how can we make developers more effective, and what is actually the effectiveness in developers. So because you can actually build great tools with decent technology. I mean, you can maybe build a great app with a PostgreSQL database or MySQL database. I know I've been working for MongoDB. I'm a little bit maybe biased in that sense. You can maybe develop it a little bit faster with a MongoDB, but still, it's the same great app that you can build with these technologies. You can use Java, you can use Kotlin, you can use PHP, maybe, I don't know. It's going to be tricky here. So let's take a step back and think about like what an effective developer is actually doing. Right? So when I think of an effective developer, I think about like they're writing super smart code. Code that you actually do normally in 20 lines of code, right? And then they condense that to just 5 lines or 2 lines or 3 lines of code. It's just amazing how effective these developers are. They're fixing bugs immediately. If you meet them actually, and you look into your GitHub issues or Jira or whatever you use as an issue tracker, there's a new bug reported over the night. You ask, hey, can someone please fix that bug? Because it's a little bit annoying. So this effective developer raised their hand and says, you know what, I actually saw that yesterday evening already, so I just like fixed it. It's actually on the main branch, so I submitted it to the main branch directly, and it's done, right? They fixing bugs immediately. So it's really amazing, these effective developers. Also, they adding new features like a champ. If you stay in the morning in front of the Scrum board with them and say, all right, this task, who's going to do that? And then this effective developer raised their hand and said, you know what, I already did that. You can progress this in progress. Actually, you can do it, or it's already done. Super, super effective. And they never stop. They always hacking. You see them always hands on the keyboard, always doing stuff on the keyboard, always in motion. These effective developers, if they have to stop, because maybe they need something from the designers or from operations, they just take the next task from the to-do list and just work on that. They never stop. They're always hacking. And they actually live and breathe code. They know the code inside out. You can actually wake them up in the middle of the night, just like say, okay, hey, the web page is a little bit broken, and then this effective developer just says, oh yeah, well, go to that class, that function, change the variable, and then it should work. They live and breathe code. They know the code inside out. They care about the code. That was actually me in 2003. Yeah, no, it's a long time ago. I'm that old dude. I was 3 years in my first job, and I felt super effective. I knew the code. I knew everything. And I felt like I am super effective. People can come to me with tasks and issues, and I will fix it. I'm super effective. Now, almost 20 years later, looking back, I must say, was I really that effective? let's take a look at what I just said with the effectiveness that I had maybe at that time. Super smart code, you know, code that is condensed just from 10 lines of code into 2 lines of code. I felt like I know what I'm doing. It's super cool code. But that was, at the moment, of course, super cool, because then I said, oh, please don't touch that code, because actually, at that time, I knew what it was doing, but now I know it's doing the right thing, but please don't make me change it. Or I was fixing all the bugs, right? Fixing all the bugs immediately. Why did I fix all the bugs? Because I felt embarrassed, actually. I have bugs in my code? No. So I just like fix it, make a fast fix around it. That broke some other things, so I fixed that too. But what I actually should have done is I should have taken the time and fixed the root problem, right? If I would have taken maybe 1 day out or 2 days out, I would have saved time at the end, right? Because I was fixing bugs always and always, over and over again, and I actually made things worse sometimes, or more unstable. So I should have just taken a step back and fixed the root problem. Adding features like a champ, right? People were tapping me actually in the office on the shoulder and said, Sven, I just been to this customer, and this customer wants this new functionality. So download something as an Excel file or so, download the list as an Excel file. So I said, oh yeah, I can do that. Let me just like hack it in and it's done, you know. But I actually created features that get never used or rarely used because this customer never bought the software, or this was just the only customer that wanted this functionality. So I actually should have worked on more popular features than just the ones that just like give us the next customer. I should have worked on features that give us the next 10, 100 customers actually. I never stop, always hacking. As I said, like stop, take the next task, wait for the designers to come with the design, and then continue with the previous task. Well, that is a lot of context switching, and we need to avoid context switching. If I have to switch between 3 different tasks each day, then I'm losing time. You know, when you're on the flow and you need to get into the flow, it takes you up to 15, 20 minutes until you're super productive and you're in the flow. I should have actually asked the designers before I actually started with the task, is your design ready when I need it? Or should I wait with the task? Because it stops and I have to do something else. So not super effective, actually. And then live and breathe code. So I knew the code base inside out. I was caring about the code. It was actually my team's code base, and I knew every line of code. Maybe not every line of code, but most of it. I felt really, really familiar with the code. But instead of just caring about the code all the time, I should have taken a step back and see the broader view of the whole product that we are building, right? Where is this product going? What features are actually used? Well, how can I improve the product instead of just thinking about code day in, day out? So, as you see, if I would have pushed on the left-hand side here, right, do more of this, I would have been more efficient, right? I would have fixed more bugs, I would have maybe added more features. Great, very efficient. But actually, effectiveness was more on the right-hand side, right? If I would have caused root problems, that would have been more effective at the end. In other terms, if I would have pushed myself to the left-hand side, I would have worked harder where I actually could have worked smarter. And that's actually also in the title of my talk, work smarter, not harder. Who wants to work harder? No one. Great. Who wants to work smarter? Yeah, that's what I want to see. Great. You're in the right talk. You can stay. No beer yet for you. So let's start with some team code to be more effective, right? We write code as a team. So writing good code takes time. We know that. Writing really good code takes time. And sometimes I was sitting like this in front of the screen, and my boss came and asked, Sven, what are you doing? Why do you try to optimize the code? The compiler doesn't care, right? And yeah, maybe he's right? The machine doesn't care. Maybe my boss was right at the time. But there's one thing, right? humans do. It gets compiled to bytecode and to machine code and get executed by the machine, but humans do. They care about well-written, good code. And this is important because actually we read code more often than we write code. So we just like look at code more often than we actually type in code. That's a fact. So you want to just like change something, so you need to just like find the right class, find the right function, try to understand what's going on. Is that the right class? No, it's not. So we read code very, very often. So we need to just like be trained into reading code so we get the functionality quickly. So if you look at code as this, well, I can highlight a few things in there, but if I look at this, I don't really get what's going on here. So then I type in git blame, and so just like blame the person that wrote that code. And then I found out, oh, it was me. And I remember it. Oh, yeah, it was on a Friday evening. Yeah, I pushed it on the main branch, and then I left it there, and I wanted to fix it on Monday morning. But you know, Monday morning was some emails in my inbox, and I just like some other stuff had to do, so I totally forgot about it. Sounds familiar? Yeah. Done that several times. So I look at the code and say, oh, there's a lot of stuff wrong here. Just let's do this, public, private, protected, what the heck, all the same. Print information where we should use camel case here. Then all the indents, just like wrong or messed up. I know a lot of stuff can be fixed here. There's like curly braces on the same line, on a different line. What the hell is going on? Just like this magic number in front of the variable or just look behind makes me always think like what's going on here. So the code is a little bit not readable, or just like the variable names, deduction A, deduction B. What does that mean? So I know there's a lot of stuff that automatic tools can do, and we should apply them, right? We should apply the same format. And formatting is not just like make it look nice, but it makes the code more readable. And I don't care about like if the curly braces is on the same line or on the next line. I don't care about this right now. We can have a conversation about that later, but it's just like what the eye gets trained to. So you need to train your eyes to well-formatted code, and you need to format code as a team. It doesn't help if just like one team member formats the code different than another team member. You have to agree on something here. It's a little bit like this. The human mind does not read every letter by itself, but the word as a whole. If you look at the code, right, you just like you want to understand what's going on. It's just like if your eyes are trained to it, you just like get it. Okay, I have to fix it here, right there. So one thing, formatting code as a team. The other thing is like writing clever code. Already been there, right? So why do we write clever code? For me, it was just like because I can, right? Because I can write clever code, I wanted to show that I do, right? To my coworkers, what smart person I am. But it was not good for the team because maybe half of the team didn't understand the code. Even I didn't understand the code after a month or 2 months. We should always strive for simple code. It is simplicity over cleverness. If you see clever code and you think like, I don't understand it, ask the author to change it, right? To make it more understandable. Because we all in the team are working with the code. It's not just me that works with the code. It's not just this person works with the code. All of the team, we're working as a team on the code. So, question here. Is your code simple enough? How do you find that out? Maybe something is simple for you, but for your coworkers, it's not, right? Maybe not for your junior developers. And that's the thing. You should make the canary test with your code. And the canary test is actually show your code to your newest developers, to your junior developers, unexperienced developers, and say, do you know what's going on here? And maybe they don't get everything because they're junior developers and they're still learning. But if they say, okay, kind of I understand what's going on, maybe with the domain I'm not so familiar with, but I get it, then your code is simple enough. How do you do that on a daily basis? Sure, code reviews. Who's reviewing every line of code that gets into your repository, every change? A few. Okay, cool. Yeah, great. Good to see. So invest time in code reviews is, of course, to first like make sure your code is readable. On the other hand, is like to inspire your youngest developers, your junior developers, what's all possible in code, and of course to ensure different code a consistent code quality. But it's not just about that, right? So code reviews are a little bit hard. We tend to not do code reviews because we want to. And I totally understand that, because our code gets in front of all of our coworkers, right? So they see actually our code, and they just like look at the code and they say, Sven, code not good enough. So they judge our code, and that's hard. That's really hard for us, because you get immediately feedback about everything that you write. And that can be quite hard. So how can we make code reviews more pleasant? So there are just like a couple of rules that the Bitbucket team has set up for their code reviewers at that time. So they say, first, if you look at the code of a coworker, try to understand, why did this person make this decision? Maybe there was no other possibility. Maybe this person didn't know better. But try to understand, put yourself in the shoes of the author of the code. So that's one thing. Then next thing is criticize the ideas, not the people. So always just like say, I don't like that, or but never say like, oh, you're in, or something. Never ever do that in code reviews, because this is really dragging people down, and that's why we actually don't like code reviews if you have this in your code reviews comments. And then also, don't rant, right? Don't say, oh, this is awful, because no one is learning from that, right? Just make suggestions. Show people what they can do, or how can they improve the code. This is the way they learn. They learn more about it. And also don't spoon feed. So spoon feed means just like tell them, okay, exchange this line of code with that line of code, because people don't learn from that. This is not how we learn. So don't spoon feed. And then also comment on positive things, right? Just be positive. People really like that. It says, oh, great idea. That was brilliant. Didn't know that this is possible. So this is just like a few rules that the Bitbucket team set up to make code reviews more human, more pleasant, however you want to call that, to just like have a better feeling about code reviews. Make your own, whatever works for your team. The second thing that I want to talk about is learning, right? Learning is very important to be an effective developer. And when I just came fresh from university in my first job, I was super excited, like, wow, cool, awesome, wow, this is possible in code? I didn't know. Wow, automatic builds? Woo, cool, right? So we are super excited. We are keen to learn something new, right? And somehow this is actually also our industry. Super excited. So being here at a conference and see this new technology, you always think like, wow, cool. I want that actually in my production code, right? We are so excited about it. Yeah. And then you put it into the production code. And I've done that too and said, oh, wow, I came from conference and said, we need to use it. And then they shut down the library after 2 years because no one actually else was using it. And then we were just like, and I had all this thing in my code base, all this different technologies in my code base, right? So over the years, you get a little bit from being super excited about things. So let's say you just like mature a little bit, right? So this is how it goes. And then you say things like, maybe, you know, I also survived the Microsoft and serverless hype. That will go over. Or, really? A new front-end framework again? That's number 20 on my list. Scrum boards, I know what's important. Yeah, right? You don't have to tell me. Or code review, not for me. My code is perfect. The other code, I want to review, but my code is perfect, right? So, with other words, even if that is a little bit like too much, but if you get older and you're longer in this industry, you have seen things, right? And you don't want to make the same mistake twice of just like ripping out another web framework, front-end framework, and putting in a new one instead. So you become a little bit like a grumpy developer. Maybe a bit, right? Not every, of course not us, but you probably have someone had in the team that became a little bit grumpy, right? Yeah. We all know these developers. And they say, I know how to develop software. Yeah, sure, they know how to develop software now, right? But then ask them the question like, do you think actually software development is changing? And of course it is. It is changing all the time, right? Containers 10 years ago, no one cared about that. So yeah, we are continuously need to learn something new all the time. We are in this continuously learning cycle. This is just our industry, and we have to deal with it. So how do we get updates? So what I do, I listen a lot to podcasts and audiobooks. I was doing that when I commuted to work. And during the pandemic, I was not commuting that much. So I was just like working out more. So during running or something, I was listening to these things. To just like see what's out there. Don't have to dive deep into technologies, but just like know what's out there so you can grab it when you need it or look at it closer when you need it. Thank God this is possible again, going to meetups. And meetups is not just about learning, but also about like connecting. And you doing the right thing, going to Jnation, great. So please, also on the after party, connect to other people. So actually you build a network, and once you have a problem, you said, oh, I met this person at this conference. Let me just like ask, they had the same problem. So also super important. What we did at MongoDB was we were having a book club. So I'm not a big book reader. I prefer audiobooks. But we were actually, as a team, reading a book. And then we read a chapter each week. And then we met for 45 minutes each week and discussed it. And that helped me actually not just to also keep reading, and concentrate for, I don't know, a chapter, 1 hour or 45 minutes, but also to just like raise my opinion, dive deeper into topics, and start a discussion. That was pretty cool. What I did when I was a team lead, tech team lead for a team, I was doing Video Fridays, which was also pretty cool. So instead of just like, we couldn't go to a conference each week, so we just like brought the conference into our team room. And we were just like voting what talk we wanted to hear or wanted to see. And then on a Friday afternoon, 3 p.m., we watched the talk and then had a discussion as a team. It's also great because not every team member has actually, or is in their life situation to just like use their spare time to learn something new or something. So, but just like have the team, have something to learn as a team. But what I hear normally from junior developers is it's like this, like, why do you learn? Why should we actually learn all these new technologies? If I have a problem, what I do is, yeah, all the answers are already there, right? We don't need to learn something because all the answers are on Stack Overflow. Just copy-paste it. That's not what learning is about, right? We know that. So first, try to solve the problem yourself. It's important because next time you run into the problem, you need to go to Stack Overflow or Google it again. But if you have really understood what the problem was, you don't run into that anymore. So super important. If you don't can get the answer by trying solving the problem yourself, just like ask for help. But before you run and go to your coworkers and interrupt them, you know, I talked about the flow and the context switching. Ask yourself for help. There's a technique called rubber ducking, and maybe it sounds a little bit stupid, but it really helps, and I'm sometimes doing it. So you can talk to a rubber duck and explain the problem to the rubber duck. The rubber duck always smiles, which is first thing nice, and understands what you're saying. But also you're taking yourself a step away from the deep dive, narrow view problem, but just like broaden your view by talking to the rubber duck, because the rubber duck is probably not a domain expert, so you have to explain it a little bit broader. And that helps actually also to think about, oh, I could try this. And often, this was actually helping me a lot. I got the answer. But also, if the rubber duck don't help, ask for help, admit that you don't know. Don't just like try to just like use days on solving it, just like admit you don't know. Because actually learning makes new connections in our brain. We know that, no connections, we can use that later. But it's not just about learning. It's also, we need to learn to unlearn and get rid of some connections. Because some things that we learned in the past is not true anymore, right? When I was at university, I was learning like waterfall method, so develop software, that's the way to go, right? We know that this is probably not the best way. We're all agile nowadays, and people convinced me that I also should look into agile. We need to learn to unlearn. Some things are not true anymore that we learned. A super important thing. Otherwise, we become this grumpy developer that says, I know everything. I know kid. I know everything. Also, if you dive deeper and you become more senior, just like use your knowledge and become a mentor and help your junior developers. That makes you actually pretty effective because the junior developers will solve the problem. So how do you do that? So first, like, become a mentor. Tell someone, I can be your mentor. Listen to people, right? Listen to what they say and just don't come up with the answer immediately. Instead of just like asking questions. Also, give them maybe, if you see like, okay, they don't know where they're going, so give them just directions. Same as with code reviews, right? Don't rant, make suggestions. Also here, just like you give them a little bit of direction. And what is super important is not come back if you don't solve it. We have a session again in 1 week. Come back then. No, have an open door. So just like be open. So this person just like feels like they can always come back to you and ask you questions. Also super important. And the thing is, when you do that, you're surprised about the answer. If you think, okay, I know actually how to solve that problem, and why does that person really don't know, don't see that, or don't go that way? They come sometimes up with other ways, and you'll be surprised, actually. You'll be surprised that there are different solutions to the problem, and not just your solution is the right one. The other solution is maybe even better. So actually, becoming a mentor is not just like giving on your knowledge, but it's also you learn something from that. So learning, continuous unlearning, and also if you, as I said, if you become more senior, please also use your seniority as advising people. But there's one important ingredient missing here in that formula, and this is experimentation. We need to try things out. We can't just not learn from books or from podcasts or from videos. So experimentation. We need to experiment. But your boss might say, yeah, why? All your tasks that you have to do is already on the Scrum board. There's no task experimentation. That's all on the Scrum board, right? And you just have to work through the board, right? Okay, it's not all on the Scrum board because it doesn't fit, so the rest is somewhere in the backlog, in Jira, you know that, everything is in Jira. So, but you also might know that this one thing like that might not be the best idea. Or maybe there is something on the board that might not be the best idea and you can't point at what it is, but you know that everything that is on the board can't be right, can't be the best idea. So saying you have known unknowns. Like, I mean, if you know, like, maybe there's a better solution out there. Maybe that's not the best solution that is on the board. Maybe actually there's a new technology that could help us. We are reinventing the wheel here. There's always already something out there, but we don't know it. Or even we're working on the wrong things. It's not, we shouldn't work on these things. We're missing some opportunities here. I can just like say one sentence to that. Don't be shy, just try. Try things out. Get your hands dirty. So what we did was we were doing taking 1.5 hours each week off, and we did coding sessions. So we were learning a new coding language, a new programming language that we weren't using at work. We were not supposed to use it at work, but we wanted to. So we took 1.5 hours from our work time off to learn something new, just to see like how things are done with maybe TypeScript, if you want to go into that. So try that, and the good thing is you take the time off as a team. So the whole team actually is engaged and takes the time off. So 1.5 hours of coding means 1.5 hours of improving. Great. But also you should look at your tools, right? You have probably 20, 30 different kind of tools that you use. Do you use them effectively? Do you know actually if you use all the features that are possible and that could help you, or maybe a new update brought new functionality and you weren't following up? So also just like invest time and just like learning your tools, or learning new tools. If you use Jenkins, maybe GitHub Actions is an option. Just try it out and see how it works. Or if you maybe you want to try some IDEs, cloud IDEs like Gitpod, where there are pre-built dev environments in the cloud, so pre-compiled for you. Maybe you try it out. These tools are normally always have a free layer, so you can try it out. So let's say invest half an hour a week, or maybe 1 hour a week, up to you. That's 2 hours of improving. But what we really want is like missing opportunities, right? Maybe you're missing something that we don't know that would help us actually to build better software, to build better products. And that's innovation. Every company wants innovation. The problem with innovation is never that you're lacking ideas. I have tons of ideas. My coworkers have tons of ideas. The problem with actually innovation is that we don't have time to try it out, to see, is that really something that would fly, or that works, or that people would really want, right? That's the problem actually that we have. So if the problem is the time, so how much time would you need? Maybe 40 hours, right? Actually, that's what MongoDB does. MongoDB takes off 2 times a year, 40 hours, so a week, to work on some problems or to work on some new ideas. They call it skunk works, so the whole engineering team, design team takes time off to work on something that they wanted to get solved. Maybe you need 30 hours. But maybe you just need 24 hours. That's actually what Atlassian does. They do this 24-hour hackathons. Actually, they were the first, one of the first that invented these 24-hour hackathons back in the days. They called it at that time FedEx days. So you get it, FedEx, deliver in 24 hours. So you had to deliver everything in 24 hours. And that became super popular. So popular, if you Googled FedEx, the FedEx days came up first, so FedEx called Atlassian and said, can you please rename your FedEx days to something more, something different? And then they called it Ship It days, same concept, to ship something in 24 hours. But this is actually a pretty easy framework that Atlassian set up here. So 3 phases, the B for the planning phase, super important to plan the dates 2-3 months before, so everyone can just schedule their off-sites or releases not at the time of the ship it day. Then they actually announce and tell stories, so that means that they think about what they wanted to work on before. Actually, they're not going into the day and say, well, what are we going to do? So they think about it before, and then they're trying to find teams, because you have more impact as a team. So they're doing this brown bags, lunch talks, where they pitch their ideas and say, oh, we need a designer for just like getting these ideas, and then not everyone has ideas or knows what's doing, and then they can join a team. So, and then on a Thursday afternoon, 3 p.m., the ship it day starts. The clock is ticking in the office. There's a big clock that is counting down. Have fun, because you're working on a problem that really that you want to get solved, and you can do so much in 24 hours if it's really a problem that you think is a problem, and that you want to show to the whole company that you can solve it. So you have the possibility to show it off to the whole company. So it's very engaging. So having fun is very important. Of course, get energized and drink. Don't forget to drink. So these are 24 hours, right? So we start at a Thursday, 3 p.m. Most people go home at 10 p.m. maybe, or 9 p.m. Some people staying, actually. There's just a few people that really stay for the whole 24 hours. Crazy people that sleeps under the desk. But most people come back at 6 or 7 and then continue working on their project, continue working on their presentation, because this is also super important. And then on a Friday, 3 p.m., we are having the presentation. So presenting, each team gets 3 minutes to present their ideas. Then we vote. Actually, actually, the voting app is also a project that was developed at the Ship It Day. So, and then we announce the winners, have a short celebration because everyone is tired. And then also, some things go on the product roadmap, but not everything. Not everything is just like a great new idea that goes on the product roadmap. And you know what? This is super important because something actually, as I said, get on the product roadmap. And these are just like a minority. But the most of them is just like, we're not doing it. And this is important. Important is really to know what you shouldn't do, which direction you shouldn't go. It's a super important learning that you have through the Ship It Day. It's not a waste of time and just like saying, oh, we just like from our Ship It Days, just like 2 ideas in the last 2 years made it into the product. Well, you learned a lot by not shipping, right? Maybe you would have put it on the product roadmap and would have been a failure. So super important that you know what you not ship. So let's do it every quarter, right? 24-hour hackathons every quarter means 0.7 hours a week. Means 2.7 hours of improvement. But then also you have the known knowns. The thing that you know are important, like your cool, great ideas, right? That you want to have in the product, but I don't know, the product manager doesn't see it, have other priorities, but it would really be great to have that in the product. Or you have this, what I call paper cut issues. So you probably know the term paper cut for small issues that you have. Let's say you have to just like do 2 steps where you could just like do it in 1 step, but we never have time to fix that, so we leave it in the software, right? It's not important. But these are small paper cut issues that you have in your software. So, and then there's a term like death by 1,000 paper cuts. So if your software is full of these small things, it feels buggy. You can do whatever you want, you can have the greatest features, but it feels buggy. So fixing those paper cut issues is also important. So how can we do that? So the Bitbucket team came also up with this great idea to run every 8 weeks, take 1 week off, and fix something in the software that isn't really a priority, but it's also important. Like they called it innovation weeks. It's a big investment, like every 8 weeks, just taking 1 week off. But it helped them also to do it as a team. Before, Atlassian had a system like the 20% time from Google. I don't know if you heard about it, just like taking 20% off. Didn't work because people were just like doing things, and then the team just like said, okay, but we have sprint goals, so why not you working on the sprint goals? But yeah, I have the possibility to work 20% on my. So we fixed that by saying we're doing it as a team, taking a whole week off. So that is our 20% time, even though it's not 20%. But this innovation week is, of course, a big investment, 5 hours a week, so it's 7.7 hours of improvement. You can make your own calculation, your own formula, but it is important to invest time in discovery, right? To invest in discovery time. You need to just like learn, know, improve your products. This is all done by experimentation. But the biggest thing that makes you an effective developer is work on what matters. So I recently browsed the internet and I found this great new functionality in a car, right? So you can control the car by gestures. Isn't that great? So you can just like turn the volume up and down. You can actually even also just like pinch zoom into something. That's so cool, so great. Why did they build that? Right? What's different than doing a touchscreen? There's probably a lot of teams involved in that because there's a camera behind the hand that's just like scanning the hand and scanning the movements of the hand. And why did they build that? Why didn't they just like say, okay, touchscreen can do the job. We have bigger fish to fry or bigger things to do, right? What's the problem they wanted to solve that a touchscreen couldn't solve? What's the problem? It's just like right in front of the screen, so it's just like a few centimeters away. I don't know. And we don't ask ourselves the question too often, like, what is really the problem we want to solve here? We always often go into the solution already and say, oh, we need to build this download button so people can download this, the list as a CSV file or Excel file. But what's the problem really that we wanted to solve here? Why do we want to solve it? What's the validation data? And what other solutions are out there to solve this particular problem? We need to take some more time to think about this. So Atlassian also developed a thing they called it the project poster. And they have really thought about this. I think it took 3 years to come up with all these questions or to fine-tune the questions. So every project that starts there now has to start with a project poster. Of course, it's not a poster. It's a Confluence page somewhere, right? So they just like start with it. And these are the questions, say, why are we doing this? How do we judge success? What are the possible solutions? Validation, like where's the data? How's the data showing that this is a problem? And then looking, when you've done it, that you really fixed the problem. So you look at the data again and see, OK, we fixed it. And then if it's ready to be made. So start with the project poster. It's not only good for just like thinking deeply about the problem as a team, so the whole team actually understands what the problem is and why they are doing this feature, but also for people that come in and say, what are you doing? And then you can just like, OK, here's the project poster, read through it, it's all in there. And then you break it down into small little user stories, right? So let's say this is a user story here. As a user, I want a new statistic button so that I can see the number of data sets. Could be a user story for MongoDB, so people can see the number of data sets that is in a MongoDB. But also here, like, what's the problem we want to solve? Why are we doing this? We also have to do this with user stories. So say, instead of this, we should say, as Yasmin, I want to know the number of data sets so that I can play for growth. So maybe if the database grows too much, you have to buy a bigger instance of MongoDB, or you have to just like shard your data into different shards. But this is really the problem that you want to work on, right? You want to know, you want to plan for growth. You want to see like when is the time that I need a bigger database. So think a little bit more like your users. So here are some users here. Jasmine, developer and training. She wants the button. Great. Then Lucas is a full stack developer. Maybe Lucas wants a command line interface, so just like he can type it in. Maybe he's more comfortable with that. So also here, like think like your users. You have different users with maybe they have the same problem, but they solve it differently. Also think a little bit like users. Of course, these are not real users. These are personas. So we made up these persona cards here, where we learn a little bit more and feel a little bit more like our users at MongoDB. All right, now you have all this kind of project posters, right? Now comes the problem of prioritization. And you know, who screamed the loudest? You're working on it. That's not the right thing to do. We all know that. So what should you work on? Work on the happy path, right? Where 80% of your users stays if you do products for users. Just like work on the happy path, because you're fixing things for 80% of your users. If you work on the corner cases, could be also important. I don't want to say that, but try to fix that first. So make your 80% of your users happy. So you can do something like this journey mapping. Maybe you've heard about it, where you just like have the journey. That's, I think, a Confluence journey map that the Confluence team put together. So you have how the users go through the software on day 1, day 2, what issues they have, and how we want to fix that. And then we do it for every kind of persona. Great, right? All right, this is developer conference. Sven, what I'm doing here. I'm just like talking about products. It's not a product manager conference, right? I'm wrong. Sorry, I took the wrong turn somewhere here. It's all about code, right? We care about code. The product people care about the product, right? Yeah. So I wish engineers spend less time understanding the problem and more time coding. Who said that? Who said that? Nobody ever, right? Nobody says that. We need to understand the problem. Even though we are coders and developers, we need to understand what's the problem of the users. So instead of, and I say, like, if you're a junior developer, maybe you want to care about code. Or you should care about code first. But once you get a little bit more mature, you should care about the product that you build, because this is actually what makes the money for the company, right? So you should become a product engineer. A product engineer. So how do you help actually the product teams to make the product better? You're the bridge between the product people and the code. So you can go in and do hallway testing, just like show your software to your coworker and say, how this new functionality, or to another team and say, they're actually experts. So just tell them, so we built this functionality, what do you think? Just give feedback before actually the product team goes out there to the users and ask the users how good the software is, or if it's working for them. Send your developers on support, right? Help them to understand the customers. And it's amazing. At Atlassian, they had this program where they sent a developer a week per year on support. It's not too much, right? But spending a week with real user issues, they came back and said, wow, they have this particular problem, and we can fix that in software very, very easily. And I don't know, 20% of the support cases will be easier to handle for the support team, and the users will be happy. So send your developers on support so they actually talk to users and learn the problems that your users have day in, day out. And also dive deeper into just like analytics, like how are your users using the software? It's not just the product managers that need to understand that. We are actually down at the wire, and we can just like do that as software developers. We can help them to understand the behavior of the users better and improve that. All that makes us actually effective software developers. Code as a team, right? So we are working as one team on the code. Continuously learn, right? We need to just like, our industry is just like continuously moving on, and we need not to understand everything really deeply, but we need to understand what's out there and how it can help us. Experiment, try to run some experiments, right? Do coding sessions, do maybe hackathons, or just like try things out, get your hands-on stuff. That you probably is not your product and your day-to-day job, but it's important. And also work on really what matters, what turns the needle, what's important for the customers. Now, I've been talking now for 55 minutes here, so you might think like Sven, for me it's still a little bit like being effective, right? It is like this. Some things works for you, some things doesn't work for you. It's a little bit, it's not just, this is the rule and here how we do it. You have to try things out, and you have to come up with your own software development effectiveness. Efficiency is super straight on, because you can measure things, you can make it more efficient. And don't get me wrong, efficiency is also important, right? We need to be also efficient to just like automate stuff, right? We do need to do some automation and automate as much as we can. We need to know maybe the command line makes us more effective, like if we use the command line tools more, or just like doing processes, how we handle the work directly. So also this makes us more effective. And this is, we got easily dragged to effectiveness, where we also should look more at efficiency, and we should look more at effectiveness. So efficiency is about like getting more stuff done. We can get more stuff done, more issues fixed, more features implemented, where effectiveness is about like getting the right stuff done that turns the needle, that helps the users, that helps maybe also the company. In other words, like this is about, efficiency is about output, where effectiveness is about outcome. So one thing, think outcome first, be effective, and then get shit done. Thank you very much. I've just let one more ask. We are this small little startup from Spain, as I said. We want to learn more about the local markets. So if you could help us, just like filling out a survey. We won't spam you, guaranteed. So if you help us filling out a survey, and we guarantee you, we send you a T-shirt for that, a nice developer T-shirt. So thank you for that. All right.
Here you go. So time to question. You still have 2 minutes to go, so please raise your hand if you have a question. And yes, if you are online, please put your question on YouTube. Or if you are here, let's raise your hand, you can put your question on YouTube as well.
When is beer o'clock? Oh, was that a real question? I think everyone is just like thirsty and want to get.
Yeah, everybody's looking for the beer.
That's fine. I'm hanging around too at the beers, so just catch me. So again, thank you very much. Thank you for coming, and have a great evening. Thanks.
cœur manque un beat, son rythme s'accélère. Un peu plus vite. Entrer dans le contexte, on dit dans le vortex. Disco. Les impacts sur les murs me laissent perplexe. Je goûte l'atmosphère du lieu, le côté rétro du Starshine. Quelques nains de cuir, ça donne une partouze mentale. Haut bas, grosse moustache. Je me fais appeler Jean-Jacques par une fille au sourire silex qui procrastine. Je décide de me mettre en position fétale. Soudain, elle me féconde in vitro. Mon cœur manque un beat, son rythme s'accélère. Et je finis par vider mon chargeur sur les nains de cuir. Derrière leurs grosses moustaches, je cherchais qu'à m'amuser. Black cats dancing on the strobe. Strange bats hanging from the wall. Tendu dans le vortex, entrer dans le contexte. Disco. Mon cœur manque un beat, son rythme s'accélère. Et je finis par vider mon chargeur sur les nains de cuir qui derrière leurs grosses moustaches ne cherchaient qu'à me vider. Black cats dancing on the strobe. Strange bats hanging from the wall. Tendu dans le vortex, entrer dans le contexte. Disco. Still
If we listen to the higher self, our experience of life is joyful and abundant. When you see yourself connected to something bigger than yourself, you no longer feel you must do it all alone. Your sense of power becomes highly magnified, and your fears are greatly diminished. With the universal energy on your side, you can learn to trust
their own child who lives beyond all that we could know. You're tired, out of base, and half of the moon's face has a stare below, reflecting onto you. It serves to remind it could take you a while. These things move forward. It won't be too long. Eyes open, lights on. Time to make your mind up. Is it yes or no? It all comes down to you. With all that in mind now, hold on to your lifetime as it spins away through all time and space.
Oh! Espera aí. Deixei tudo por ela, deixei. É a única coisa que eu sei cantar. Ok. Pessoal, vocês são os Die Hard, ficaram aqui até o final. Obrigado a todos por terem ficado aqui, por terem vindo no evento. Se calhar devíamos ter feito isto quando viemos todos para cá. Steampunk.
Let me do it.
No brand.
Obrigado.
Oh,
Cuidado só com
aqui. Sim, desculpa.
We're wearing the brand.
Obrigado a todos por terem vindo mais uma vez. Vamos fazer aqui uma cervejinha. Cheers.
Cheers.
Para o ano voltem, tragam um amigo. Ou dois. Todos que puderem. Obrigado. We're done.
All right.
Thanks, man.
Great job.
Do you feel better? Are you going to feel better? Are you going to feel better? Are you going to feel better? Do you feel better?